Shall we start now?
Yes, please, ma'am. We can start. Good morning.
Very good morning, everyone. Today we have with us Dr. J.B. Prajapati, sir, retired Principal and Dean, SMC College of Dairy Science, and Coordinator of Swedish South Asian Network on Fermented Foods. Coordinator of this workshop, Dr. Subrata Bhatia, Assistant Professor at SMC College of Dairy Science. Co-coordinator of this workshop, Dr. Srija Madam, Head of Dairy Microbiology Department, SMC College of Dairy Science. Dr. Atanu Jana, sir, co-chairperson of this webinar and principal of our college. Distinguished members from BIREC team, Dr. Shilpi Madam, Dr. Sujit Das, and the other members. Invited eminent speakers and all the participants who joined us virtually. I feel privileged and honored to welcome you all again on behalf of organizing team to the second day of two-day webinar on biomanufacturing of probiotics and fermented foods, a step towards health status and social well-being. Today we have with us three highly experienced and learned speakers from academia as well as industry. They are going to speak on different topics such as fermented milk products, role of lactic starter culture, future of fermented milks in the era of ultra-processed food pattern, and probiotics, criteria, mechanism, and clinical evidence. And then we have open discussion session where all the questions asked by participants will be answered by the respective speakers. Our beloved Dr. J.B. Prajapati sir will act as a coordinator of this session. So I request all the participants to write your queries in the chat box and your questions will be answered during open discussion. Now let us start with very first eminent speaker, Dr. Srija V. Madam is Assistant Professor and Head at Dairy Microbiology Department at SMC College of Dairy Science, and she is going to deliver her talk on fermented milk, role of lactic starter culture.
Sujit, kindly make Madam presenter.
Yes, ma'am. You can start sharing your screen.
Okay, Dr. Sujit.
Screen is visible, Sujit?
Absolutely. You can put in the slideshow. Yeah. Perfect.
Thank you, Dr. Mittal. A very good morning to one and all attending this seminar. Respected Dr. J.B. Prajapati, Chairman of this particular session, Principal of SMC College of Dairy Science, Dr. Atanu Jana, BIRAC, DBT BIRAC members, Dr. Sujit, Dr. Shilpi ma'am, and my colleagues, as well as coordinator, Dr. Subrata Bhatia, Dr. Mittal, and invited speakers, Dr. Sanket, Dr. Nirja Hajela. So very good morning to one and all. So what I'll be covering in my this particular lecture will be about the lactic starter cultures, biomolecules elaborated by the lactic starter cultures, their role in fermented milk products, role in human health, and I'll be giving an overview related to studies which are being carried out at Dairy Microbiology Department, SMC College of Dairy Science. probiotics. The long history of consumption of fermented dairy products talks about its generally recognized as safe status, and it is considered as a source of bioavailability of nutrients when consumed. To the new generation, these fermented milk products occupy a pivotal position in their daily diet because of the healthy image, and these products are considered as healthy snacks. Fermented products are prepared using fermented milk products are prepared by fermenting the milk using starter cultures. The dairy starter cultures are very broadly classified into lactic and non-lactic starter cultures. When we talk about the starter cultures, these are said to be the heart of the fermentation industry. And these starter cultures are being selected for performing certain functions, and they should be pure and actively growing microorganisms. We use them in single or in combination to bring about desired changes in the milk to produce the fermented milk products. Now, these dairy starter cultures, they can be used to start the fermentation process, or they are being used to impart the special characteristics also, and also to provide specific health benefits. We call them as probiotics. Now, in the lactic starter cultures mainly includes the bacteria, and in the non-lactic starter cultures comes bacterial species, yeast, as well as molds. Now, if you see the lactic starter cultures, it includes the initial, according to the initial classification, the core group. In that comes the members of the genus Lactobacillus, Leuconostoc, genus Pediococcus, and the Streptococcus. Later on, with the advancement in the molecular techniques, new genera has been added to this, and accordingly, the rod-shaped lactic starters, the members belong to genus Lactobacillus, genus Carnobacteria, and some Vacella species. Whereas at the same time, in the cocktail-shaped or lactic starters, the species belong to genus Aerococcus, Dolosegranulum, Enterococcus, Lactococcus, Oenococcus, Tetragenococcus, etc. I have shown here a nomenclature regarding some of the prominent Lactobacillus probiotic species. For example, Lactobacillus casei, which is being currently given the new name Lacticacibacillus casei, Lactobacillus paracasei, Lacticacibacillus paracasei, and Lactobacillus rhamnosus, casei Lactobacillus rhamnosus, and so on. And some of the species their name has remained unchanged. When we talk about the common characteristics of lactic starters, they are basically gram-positive cocci or rods, non-spore-forming in nature, non-pigmented, and they are unable to produce catalase and cytochrome. Hence, growing anaerobically, but are aerotolerant in nature, and they can ferment sugar with lactic acid as the major end product. The nutritional requirement of these cultures varies from species to species, and most of the cultures are nutritionally fastidious in nature, often requiring specific amino acids, vitamins, nucleic acids, and other growth factors. Regarding their metabolism, lactic starters are chemotrophic in nature. That means they find their energy requirement through metabolism or oxidation of the chemical compounds. So oxidation of sugar constitutes the principal energy producing pathway, and two main sugar fermentation pathways are distinguished among the lactic starter cultures. Change के नहीं हो रहा है. Okay. So lactose metabolism, when we talk about fermented milk products, starters to transport lactose across the cytoplasmic membrane. And the first one is the phosphoenol pyruvate dependent phosphotransferentative lactate starter. For example, lactococcal species. In this system, the lactose is phosphorylated while during its passage across the cytoplasmic membrane. And this lactose 6-phosphate, which is being taken inside the starter culture cell, is hydrolyzed to glucose and galactose 6-phosphate by the glucose and the galactose are then catabolized by the Embden-Meyerhof-Parnas pathway and Tagatose pathway, respectively. So the same is being shown here. The lactose 6-phosphate, which is being taken inside, is converted into galactose 6-phosphate and glucose inside the cell, and which is then further catabolized to lactic acid and through the Tagatose phosphate pathway and through the Embden-Meyerhof pathway to lactic acid. The second system for taking lactose inside the starter cell is with the help of lactose permease. So the lactic acid bacteria which utilize this system include Streptococcus thermophilus, Lactobacillus species, Bifidobacterium, and Leuconostoc species. So lactose enters the cell via a permease without any phosphorylation. This lactose is then hydrolyzed by beta galactosidase to glucose and galactose, and the glucose and galactose are then catabolized by the Embden-Meyerhof pathway and Lilloyer pathway, respectively. So in case of homolactic fermenting starter cultures, the major end product is the lactic acid, and 1 mole of lactose, which is being taken inside the starter culture, is converted into 4 moles of lactic acid. So for homofermentative lactic starters include the Lactococcus lactis species, Streptococcus thermophilus, Lactobacillus helveticus, etc. Whereas in case of heterofermentative lactic starters, this lactose is catabolized by the phosphoketolase pathway, as shown here in this. So this pathway results in the formation of lactic acid, ethanol, and carbon dioxide. And some of the species which follow this pathway are Lactobacillus casei, Lactobacillus paracasei, Lactobacillus plantarum, Vasella, etc. Shown here is the lactic starter cultures are associated with fermented milk products. Our traditional fermented milk product, well-known product is dahi. The starter culture used for dahi comprises of the acid producers such as lactococci and flavor producers such as Leuconostoc species. The yogurt starter comprises of Streptococcus thermophilus and Lactobacillus bulgaricus. And some of the non-lactic starters are also being used as part of the starter culture to produce certain fermented milk products. An example is Roquefort cheese, where along with the lactic starter, like this particular mold, Penicillium roqueforti, is used for getting the typical product characteristics there. When we talk about the role of lactic starters in the fermented milk products, a number of metabolites are being elaborated when these lactic starters ferment the milk. These includes organic acids such as the lactate, acetate, when we use the acetic acid bacteria as part of the starter culture, carbon dioxide, bacteriocins, flavoring compounds like diacetyl and acetaldehyde, number of enzymes, beta-galactosidase, proteinases, proteases, and peptidases, as well as lipases are being liberated during the metabolic activity of the starter cultures. Depending on the species, exopolysaccharides, certain therapeutic bioactive peptides are being also produced. And some of the vitamins, especially the vitamin B complex membranes, are being produced during the fermentation of the milk. So these metabolites, which are being elaborated during the fermentation of the milk by the starter cultures, contribute significantly to the product characteristics, its quality, its biopreservation, as well as its biosafety. One of the most important step in the preparation of many of the fermented milk products is coagulation of milk. So the extent of souring can vary depending on the type of the fermented milk product, and the starter culture changes the milk sugar lactose into lactic acid. So the milk becomes sour. And lactic acid reduces the pH of the milk, and this leads to a progressive solubilization of the micellar calcium phosphate, and this demineralization of casein micelles and their destabilization happens. This generates the complete precipitation of casein in a pH range of around 4.6 to 4.7. And this lactic acid also contributes to the acidic taste as well as the flavor of the fermented milk. In addition to that, it also imparts a preservative effect owing to its antimicrobial activity. Another very important role that the starter culture is contributing to the fermented milk production is production of flavoring substances like diacetyl and acetaldehyde. Diacetyl contributes the typical buttery aroma and flavor to products like dahi, cultured buttermilk, cultured butter, sour cream, and some of the cheese varieties like Gouda and Edam cheese. Acetaldehyde is considered as the major flavor compound of the yogurt. In small amounts of residual citrate, which are present in certain cheeses, are being metabolized by the mesophilic starter cultures like Leucrostock species through the citrate fermentation pathway. And these citrate positive strains of Lactococcus also generates compounds like diacetyl that contribute to the flavor of the Dutch type of cheeses. These flavoring compounds also possess antimicrobial effect and contributes towards the preservative effect of the fermented milk products. Another very important activity the lactic starters or starter cultures are playing is proteolytic activity, that is conversion of proteins to polypeptides and further to amino acids. So lactic acid bacteria basically require nitrogenous compounds to sustain their growth. So they use the milk protein as a source of nitrogen, and they degrade this casein and peptides to meet their amino acid requirements. In general, the proteolytic system of lactic acid bacteria is said to be weak. Yet, the proteolytic activity of starter bacteria play a very important role, particularly in ripened cheese varieties. So the proteinases which are being elaborated by the lactic starters hydrolyze the proteins to polypeptides and then further to smaller peptides with the help of enzyme peptidases and further to amino acids. Now these amino acids are being further catabolized to aldehydes, alcohols, carboxylic acids and thioesters, which contributes to the flavor of a number of ripened cheese varieties. Proteolytic activity also leads to the generation of specific protein fragments that have a positive impact on the human body functions and conditions and may ultimately have an influence on the human health. These bioactive peptides with various bioactivities have been identified in several of the fermented milk products and in many cheese varieties. So here you can see a number of cheese varieties as well as other fermented products like yogurt and dahi. And these are the identified bioactive peptides from such milk products, and their health benefiting aspects are listed here. So most of these active peptides, especially identified from the cheese, is found to possess ACE inhibitory activity and also immunostimulatory activity. Shown here is work which is carried out at Dairy Microbiology Department, SMC College of Dairy Science. So we have used our own lactic strains which are being isolated, identified and characterized by us in our department. And these cultures are being used for fermenting bovine as well as non-bovine milk species from the indigenous breeds of milch animals. And bioactive peptides possessing ACE inhibitory activity as well as antioxidant activity are being identified. And these sequences are being submitted to the biopep databases for the benefit of the scientific community. Another very important activity that the starter culture is performing when it carry out fermentation of milk is the lipolytic activity. A weak lipolytic activity is considered a desirable attribute in the preparation of fermented milk products. So the fatty acids which are being produced contribute to the flavor of the fermented milk products as well as it imparts health benefits. So the milk fat or milk triglycerides are converted into diglycerides and further to monoglycerides with the help of various lipases, enzymes, and finally to fatty acids and glycerol. So this particular process is very important during the accelerated cheese ripening also. So the activity of proteases, lipases, peptidases, all these contributes to the cheese ripening, affecting its body and textural characteristics as well as the flavor of a number of cheese varieties. Now, these free fatty acids, they directly impart a flavor to the various cheese varieties, and also these fatty acids can act as precursor for a series of catabolic reactions leading to production of methyl ketones, secondary alcohols, also lactones, aldehydes, etc. These contributes to the flavor of the cheese varieties. Flavor as well as health benefits. Yet another biomolecule which is being elaborated by the lactic starters is exopolysaccharides. So most cultures producing the EPS belong to the genera Streptococcus, Lactobacillus, Lactococcus lupinostok, and Pediococcus. And EPS are basically chains of polysaccharides consisting of units of monosaccharides such as glucose, galactose, rhamnose, xylose, arabinose, etc. Now, these exopolysaccharides play a very important role in the textural characteristics of the fermented milk products. So, when produced in situ during the milk fermentation, it is found to have an application as a food biothickeners. Example in yogurt and Scandinavian fermented milk product. And presence of EPS also confer beneficial physical properties to the dairy product, such as the improvement of various rheological properties and the reduction of syneresis in yogurts, better consistency of curd in the low-fat ripened cheeses, and enhanced yield, and also functionality to low-fat mozzarella cheeses. The advantage with the EPS is that its production does not add any particular flavor to the fermented milk product. So you can use it as a biothickener without compromising on the flavor characteristics of the product. So shown here is some selected EPS along with their producer organisms and its applications. So I would like to highlight regarding the kefir. It's a well-known fermented milk product, an acid alcoholic fermented milk products containing carbon dioxide also. So kefir grain is used as its starter culture, and kefiran is the exopolysaccharide which is elaborated when the culture grows in the milk. And this kefiran is found to have lots of health benefits, which includes reducing blood pressure, cholesterol, and blood glucose rates. It is found to have anti-inflammatory, anti-tumoral properties also. Number of antimicrobial compounds are also being produced when the lactic starters they ferment the milk, which includes organic acids, diacetyl, acetaldehyde, bacteriocins, hydrogen peroxide. So organic acids, like lactic acid, it causes reduction in the pH, and these acids, depending on which kind of what type of starter culture is used and what is the fermentation characteristics, the acids are found to be inhibitory towards yeast and spoilage microorganisms. So acetic acid are more inhibitory than lactic towards yeast and towards the growth and germination of the Bacillus cereus. Diacetyl is found to possess antimicrobial effect, and it is found to be more inhibitory towards gram-negative bacteria than the gram-positive bacteria. Acetaldehyde at a concentration of 10 to 100 ppm is found to be inhibitory towards the growth of Staphylococcus aureus, Salmonella typhimurium, and E. coli. Bacteriocins which are being produced during the fermentation, an example is niacin, which is the spore-forming organisms. Then hydrogen peroxide, which is produced by Lactobacillus and Lactococcus strain organisms. Carbon dioxide, alcohol, fatty acids are also found to possess antimicrobial effect towards a number of spoilage organisms. So all these are basically providing a biopreservation effect to the fermented milk products, and also biosafety to the fermented milk products. Now, vitamins are also being produced by certain cultures during the manufacture and storage of fermented milk products. Now, again, this will depend on which kind of starter you are using, because the starter cultures are considered basically fastidious in nature. Hence, they require vitamins for their own growth and maintenance. But then some of the strains, for example, Streptococcus thermophilus and Lactobacillus bulgaricus, are found to elaborate vitamins like niacin and folic acid in the fermented milk products. A study has been carried out in our department where we have compared the vitamin producing ability of Lactobacillus helveticus strain and Lactobacillus rhamnosus strain. Both are our own strains, and these and biotin during the fermented milk production, and we found that L. helveticus strain was found to be a better producer of folic acid and biotin. Both were able to produce folic acid and biotin, but L. helveticus was found to be a better producer of folic acid and biotin. And when the strains were used in combination, we could not find a rise in the folic acid and the biotin. And when the strain was used alone, it produced both the vitamins in higher quantity. So in addition to all these metabolites, low-calorie sugars are also being produced by the lactic starters. This includes sugar alcohols such as mannitol, sorbitol, tagatose, and trehalose. This is being reported in the literature. Mannitol and sorbitol are low-calorie sugars that we can use to replace sucrose, lactose, glucose, or fructose in the food products, as they display equivalent sweetness and taste. So such cultures and strains can be exploited for natural enrichment of the fermented products with these sweeteners for development of novel low-calorie foods with added functional values, especially for diabetic patients and Weight Watchers. During the fermentation process, the starter cultures multiply to a count of 10 raised to 6 to 10 raised to 9 CFU per gram. So these starter culture cells contain molds, enzymes, nucleic acids, cellular proteins, lipids, carbohydrates, etc. And the recent research reports are stating that these dead or non-viable bacterial cell fragments, which are being obtained during the fermentation process, it is found to possess biological activity that can induce certain health benefits similar to the live bacteria. So even if you give a thermal treatment or heat treatment to the fermented milk products, these functional molecules can remain in the fermented milk products, which can produce certain health benefits. So these such as cell metabolites and cell wall derived substances, which are secreted by either organic acids, which are now being put under the category of postbiotics or paraprobiotics, are being explored for potential health benefits and their antimicrobial potential. Now, coming to the health benefiting aspects of the fermented milk products, a number of health benefits are being reported, and lots of research studies are being carried out, which includes its potential anti-hypertensive activity, improvement of protein digestibility, alleviation of lactose intolerance, etc. Shown here is evidence-based efficacy of selected probiotic strains used in the fermented milks. For example, the probiotic strains are being shown here, and they are being delivered through fermented milk matrices. And the evidence-based efficacy include their role in managing constipation, antibiotic-associated blood pressure reduction. Evolus claims blood pressure reduction and reduction of stress effects by ProDiet. Coming to our contribution to fermented milk products and its health benefits, I'll take you through our journey. These are our starter and probiotic strains, which are well characterized empty strains. And these strains are ready for commercialization, and these are being studied for various functional aspects also. Streptococcus thermophilus strains are found to be good starter cultures for dahi. Is studied. L. hepaticus strain MTCC is our first well characterized probiotic strain, which is found to possess promising hypercholesterolemic, ACE inhibitory, and antioxidative activity. And it is also found to have a potential effect on skin health and vaginal health. And other two rhamnosus strains, which is found to have a promising ACE inhibitory activity and antioxidant activity. Bacillus Siberia strains are found to be good EPS producers. And the Lactobacillus fermentum strain is found to exhibit a promising ACE inhibitory as well as antioxidative activity. These cultures are available in the dairy microbiology department. So those who are interested can get these cultures from us, and we can go for commercialization of these cultures for with the collaborative efforts also. We used these strains, our dairy starter cultures and probiotic strains, for developing an array of fermented dairy products. And these fermented dairy products are studied for their potential health benefits also. So these products developed symbiotic lassi. We try to deliver these strains, or we have used our dairy starter cultures to develop millet products also. So we have developed finger millet enriched products, and the product is being studied for its potential anti-obesity effect and anti-diabetic effect. Then a barley enriched probiotic fermented milk was developed using our strains and starter cultures and probiotic strain, and which is found to have anti-urolytic potential. Symbiotic fermented dairy product containing our probiotic strain Lactobacillus helveticus in geriatric volunteers. The project was funded by DBT, and it was carried out in collaboration with the Medical College, Karamsad. This was the design, the probiotic group and the placebo group. And in the results, we found that the group has got initially in the presence of lactobacillus, our probiotic strain was not detected, but later on the presence of probiotic strain was detected in the probiotic group, indicating the ability of our strain to survive in the gut. So in the probiotic group, we administered our probiotic product, And in the placebo, we administered a similar product without the same product without the probiotic strain. So in case of effect of probiotic administration on the immunological parameters of the geriatric population, we found a significant immunomodulatory effect on the TNF alpha as well as interleukin-2 levels for the benefit of the subjects among the probiotic group in comparison to placebo group. However, no significant beneficiary effect was found on the interferon gamma as well as the immunoglobulin levels. Further, we have seen that the serum calcium level was significantly improved in the probiotic group in comparison to the placebo group. The metagenomic study revealed that fecal microflora volunteers revealed they were dominated by formicutes, actinobacteria, and proteobacteria. And the changes in the phylum composition after probiotic feeding included a 7% increase in the formicutes, 1.5% rise in the actinobacteria, and 1.9% increase in proteobacteria. And proteobacteria were found to be higher in non-responders, both among the responders and non-responders. The chief genera of formicutes that showed a significant difference were Lactobacillus, Clostridium, Eubacterium, and Protein. In another study, the finger millet enriched fermented milk product was evaluated for its anti-diabetic and hypolipidemic action. So this was an in vivo rat study, and this was carried out in a streptozotocin induced diabetic model, and the test formulation was administered for 30 consecutive days, and we found that shown here is this is the disease control, and this is the standard drug control, and fermented milk without finger millet, and this is having the finger millet. So a significant prevention was observed with the finger millet formulation, which presented around 66.37% reduction in the glucose level. Further, the rise in case of the lipid profile, the lipid profile we have seen, that is HDL, LDL, and VLDL. So here you can see that the HDL level has gone down, whereas the LDL and VLDL level has gone up in case of disease control. And this has been ameliorated to a great extent in the milk millet composite test product. And then we have also studied the effect on the liver enzymes, aspartate aminotransferase and alanine aminotransferase. So here you can see the rise in the level of both the liver enzymes, which is usually found in case of diabetes, and this is the effect of the product, and it has got a significant effect. Similarly, in case of fermented milks also exerted such an effect there. In yet another study, the finger millet enriched probiotic product was evaluated for its anti-obesity potential. So adult male Wistar rats were used in the study. This is how we have performed the experiment. So high-fat diet model was used, and it was classified as into 3 groups: the high-fat, that is the disease control, and the control, product control, and the test. And here you can see the results that we have obtained. So the terminal fat and the liver enzymes, and also the lipid profile in the DC group has been ameliorated with great extent in the test product group in comparison to the product control. So a significant difference can be seen in this case, in case of the test product. Again, here you can see that the liver from the DC group, which showed widespread this lipid vacuoles. And here you can see in the test product, which is not observed, and this was the amelioration effect was to a great extent in case of the test product. So these are the results which I have already told you. Recently, we have conducted a study where we have evaluated the anti-cancer effect of the fermented milk postbiotic against colon cancer cell line HT29. So we have fermented the milk using our probiotic strain Lactobacillus helveticus, and the postbiotic was extracted by centrifugation as well as filtration through the membranes, arterial membranes, and the postbiotic obtained was then freeze-dried and which is used in the study. So in this study, we have observed that the half maximal inhibitory concentration, that is the IC50 of CFS4 H29 cells ranged from 1 and 1.5 and 2.9. So here you can see the IC50 level. After 72 hours of treatment, so IC50 at 1, and in case of 48 hours, it was 1.5, so where the 50% inhibition is seen, and about 2.9 in after 24 hours. Further, in order to understand the mechanism, we have studied the gene expression, and we found that the pro-apoptotic genes were upregulated, whereas the anti-apoptotic genes were downregulated. So these products that we have developed are available for commercialization, and we are also doing lots of work in the fermented food area as well as bioactive peptides. Then to conclude today's this particular topic, I would like to say that lactic cultures, they play a very crucial role in converting milk as raw material to fermented milk products. And in milk fermentation industry, when we talk about lactic cultures, they are used as starter cultures, they are used as adjunct cultures, they are being used as probiotic cultures to provide specific health benefits. The functional biomolecules, which is the theme of this particular webinar, which are being elaborated by these, the functional molecules are contributing to the fermented milk characteristics, like its quality, its organoleptic quality, its biosafety, its biopreservation. In addition to that, so in this particular area, and to the taking into consideration the GRAS status of lactic starter cultures, these starter cultures can be widely used in the development of novel functional fermented milk products for the benefit of the human health and society at large. Thank you.
Thank you so much, Srija Madam, for the detailed and very informative presentation in preparation of various fermented products with potential health benefits. I request all the participants to write your queries in chat box. All the questions will be discussed and answered during open discussion session. Our next speaker is Dr. Sanket Bore. He is Technical Director at Flavy Dairy Solutions, Ahmedabad, Gujarat. And sir is going to deliver his talk on future of fermented milks in era of ultra-processed food pattern. Dr. Sanket, kindly start your presentation.
Very good morning. And can you please allow me to present my PPT? Is it visible?
We are not.
Yes.
Yes, it is visible. Yes. We are able to see slide.
Switch to the slideshow.
All right. So today I'll be discussing about the current era of ultra processed foods and where we see fermented milks in that particular dish or menu and what future lies ahead of us being a dairy technologist. I'll be covering a little bit of food and health and what is ultra processed food. What are the issues with ultra processed foods which are really critical to highlight among the audience and the general public basically? This will be more of a informatory topic about issues with ultra processed food, and then we will discuss what are the future issues that need to be addressed and what are the health benefits that are delivered through fermented milks. Although my previous speaker and my beloved teacher, Dr. Srija, has already covered the health benefits of fermented milk, but I will discuss about the health benefits of fermented milk with respect to those issues created by ultra processed foods, and we'll also discuss about a little bit about research reality and myths about the fermented milks. Dr. Mittal, your screen is getting popped up. Can you please minimize it? All right. So definition of food and health is something which is very much important because normally we get confused between word food and edible substances. So by definition of food, it's any nutritious substance. Remember, it's a nutritious substance that people or animals eat or drink or that plants absorb in order to maintain life and growth. So the two important thing here is food should be nutritious substance, and it should help us to maintain our day-to-day life and impart growth. Another definition of important parameter is health, and we normally say health is about being physically fit. But health is a state of complete physical, mental, and social well-being, not a merely absence of disease and infirmity. Okay, so the typical aspect of health, maybe most of the common consumer understand is about absence of disease. But when we say health, it is about physical, mental, and social well-being. So typically, say if any food is not typically suitable to your mental well-being also, it is not a healthy food. Okay, let us talk about nutrition in detail. Nutrients are classified into three categories broadly: macronutrients, which are responsible for calories, those are fats, proteins, and carbohydrates; micronutrients, which are essential and taken into IU or say microgram or milligrams, those are vitamins and minerals; non-nutrients, but which are essential for healthy well-being, are water and oxygen. If we consider the macronutrients, fat gives 9 kilocalories, alcohol gives 7 kilocalories, carbs and protein gives 4 kilocalories, polyols, certain fibers gives 2 kilocalories, most other fibers, indigestible, insoluble fibers, air, water, vitamins, minerals, they are non-calorie. So here we should consider that fat and alcohol are generally gold in terms of calorie, whereas carbs or say proteins or say fiber, water, vitamins, minerals, they are silver or say bronze. And you will understand why I have given you this example about gold and bronze. We should also consider this, that an average human being required around 2000 kilocalories per day. which is approximately 67 grams of fat, 65 grams of protein, around 280 grams of total carbs, out of which around 50 grams should be sugar at max, and around 30 grams of fiber with 3 liters of water. Now let us come back to our topic, ultra processed food. So the group one of food is considered as unprocessed or say minimally processed, or say those foods which are derived from the nature. So fresh fruits, vegetables, eggs, or say cereals, grains, etc. They are minimally processed foods. The group two is a process, but of a culinary purpose. Those are maybe like say after milling whatever flour we get, or maybe edible oil after pressing cereals or oil seeds, making butter out of milk, maybe vinegar out of a fruit juice, or etc. The third one is a processed foods where we use these ingredients like flour or say edible oil or butter or other ingredients to make say products like bakery products, canned juices, sausages or cheeses, etc. And the fourth one is ultra processed food. And this is the category of food where nutrients lose their originality. Say, for example, say potato chips or fried foods. So potatoes are first sliced, then they are cooked or blanched, then they are fried, and they are fried again and again. And hence, like say, uh, components generated during the intense caramelization are present in this kind of food, which are also neurotoxins or not healthy at all. Say carbonated soft drinks, maybe bakery muffins with non-dairy whipping cream or whipped creams and chocolates, hot dogs, burgers, or fried and frozen foods, etc. So these are the examples of certain ultra processed foods. We should look at these names very critically, and we should understand what are the frequency of these ultra processed foods, or what are the percentage or proportions of these ultra processed foods in the list of those 2000 kilocalories of comprises of around 67 gram fats and 65 gram protein and remaining total carbs and etc. So ice cream, chips, bread or bakery items, breakfast cereals, carbonated drinks, fruit flavored beverages and yogurts. It's not a plain yogurt, it's a fruit flavored yogurt, instant soups, some alcoholic drinks. Uh, if we talk about Indian food patterns like samosas and pakoras, some energy drinks, just like say Red Bull or Hell or something like cheese flavored crackers, nachos or say chips, which are very much in the trend, cookies, puffs and pastries, chocolates, sneakers or other energy bars, sugar boiled confectionaries, pizzas, burgers, etc. Uh, in short, most of those foods which attracts you or drive you to uncontrolled consumption outside of kitchen are basically ultra processed food. So you can see that whenever you are sitting idle, if you open your fridge or if you are visiting any mall or if you are in the restaurants and if you have a craving for anything, this could be the ultra processed food. Now, let us discuss about the issues with the ultra processed foods. During the last 5 years or so, globally, 281 studies from 36 different countries have compiled, and they are of a common opinion that ultra processed food addiction is real actually. And during those course of duration, they observed that the 15% of adults and 12% of children are genuinely addicted to ultra processed foods. We may ask ourselves as well as we may introspect to our day-to-day life We are father, we are elder brother, sister also. Those children which are there in our family or our relatives, they are also sometimes addictive. Those population of our country, they always crave for chips or something instead of yogurt and milk. And the reality of this number is really very high. In fact, some of the experts requested to label ultra-processed food to be addictive in order to reduce or in order to control the consumption of ultra-processed food to youngsters and children. Recent studies have linked the ultra-processed foods to poor health, increased the risk of cancer, weight gains, and heart disease. Now, again, we can correlate what happens if we consume one piece of burger or one piece of pizza, whether or one a serving of say, potato French fry or one serving of potato chips. Practically, it's loaded with the carbs and fat, but there are no or minimal vitamins and minerals and good quality protein, that is milk protein or egg protein or any animal origin protein or maybe veg protein like soya protein or something. So we are having the intense craving for these things because there is less of protein, there is less of minerals and vitamins and fiber, and that's why our body loves fats and carbs, and that's why body consider fat and carbs as a gold, whereas proteins and fibers, vitamins, minerals as a bronze. So our body always crave for golden ingredients or golden nutrients like fats and carbs. When we consume overloaded fat and carb containing protein products, will be leading to poor health, higher risk of cancer, CVDs, CHDs, weight gains, and obesity, osteoporosis, and heart-related issues. These 281 studies from 36 countries also reported that in the United States and United Kingdom, more than 50% of food in an average diet is ultra-processed foods. So, 58% or more calories they were derived from ultra-processed food. Last year, I was in the Europe and I observed that whatever they order for their lunch or dinner, French fries and burgers remained the constant in European population. So they had a French fry as well as burger as their staple food, and this is why more than 50% of their diet was ultra processed food, and they were drawing most of their calories from fats and carbs basically. What happens if you are addicted with UPS or inversely, these are the symptoms or behaviors. This can help you to identify whether you are addicted to ultra processed foods or not. The first one is intense craving. If somebody is showing you the packets of chips, say cream and onion chips or say classic salted chips or pizza or burger, and you develop the craving, that means you are addicted to ultra processed food. Symptoms of withdrawal, that means, say for example, if my son or my child or if your son, your child is asking for chips, and if you say no, he or she will be simply withdrawing from the communication and she will or he will feel neglected and they will sit in the corner and they will not talk to others with the same level of respect and all these things. Less control over intake. If you are dining over the table with these kind of foods like say, pizzas and burgers and pakoras or samosas or ice creams and cold drinks, and you cannot control yourself and you overeat it, that means you are addicted to ultra processed food. If you continue to eat these kind of foods, say French fries, pizzas, burgers, pakoras, samosas, despite you are obese, despite you are having a certain health issues, then you are addicted to ultra processed food. Other behaviors also include like poor physical and mental health, lower quality of life. You do not focus on consuming fruits and vegetables or healthy foods, etc. These are the symptoms that indicate that ultra processed foods addiction is real in you and me as well. Now, how are these issues actually created? We must also understand these things before we jump into any conclusion. Biologically, when we consume refined carbs and fat, so you can understand that most of these foods, whatever names were written in the examples of ultra processed food, they were fried using refined fats. Most of them are refined palm oils or palm fats or palm kernel oils, etc. And they are containing refined sugars also. Ice cream is containing lots of sugar. Indian sweets are also containing lots of sugar. Okay, French fries also having easily digestible carbs basically. Chips are also having a simpler carbs basically. So those refined carbs and refined fats, they evoke the similar level of extracellular dopamine in brain, and hence you always have a habit of having a pleasure when you consume the food, and that's where it becomes addictive. You develop the habit that until and unless you don't eat refined fat or refined carb, you don't have a extracellular dopamine in your brain, and you don't have a pleasure feeling. And that's where these substances become addictive, just as like say nicotine and alcohol, basically. So based on this behavioral and biological parallel dopamine secretion, foods with high refined carbs and fats are strongest candidate to be addictive. Any other element which are responsible for this addiction is the speed at which the dopamine is secreted in the brain. So, say for example, if you consider three main ingredients or three main nutrients, that is a fat, another one is a protein, and then the third one is a sugar. If you look at the speed at which these ingredients or these nutrients are metabolized in the body, you will identify that these simpler and refined carbs are the fastest one to get metabolized in the body and to have a higher blood glucose level and ultimately higher dopamine level. Whereas protein is the only component which is taking very much long to get metabolized in the body. So the scale, if we consider the scale of addictive potential, those food which are having a higher fat and higher carbs, which are refined one and simpler one, they will have a better score in terms of addictive potential. Most of or all of ultra processed foods are high in refined carbs and fats, so they always are highly rewarding, high appealing, and consumed compulsively and hence addictive. Now let us discuss about what are the future health issues. Okay, so the first one is acidity and indigestion. Acidity and indigestion are most commonly observed in the youngsters, and you can see those college-going students and children of children are mostly at the teenage, and those millennials of say my age, they are having a higher issue of acidity and indigestion. This data could be correlated well with the growing turnover of ENO and other acidity regulator or acidulant, something like that. So, the most common or important factor responsible for acidity and indigestion is consumption or overconsumption or uncontrolled consumption of carbonated soft drinks. Okay, most of our foods are accompanied by carbonated beverages. Sorry. Then we have a higher consumption of chips, fried foods, and most of these ultra processed foods also contains acidity regulator INS 330, which is citric acid. Now, the classical example for this is that, let us say French fry. The growth of French fry is a tremendous beyond the scale of as a percentage, and there are huge number of companies with the huge production capacities are being set up in Gujarat and other part of country, and the product 100 times down the line next 5 years. So this indicates that there is a huge growth rate of consumption of chips and fried food in India against the consumption of say dahi or fermented food, which is around 14-15%. So growth rate of healthy food of say dahi, yogurt or buttermilk is 14%, whereas the growth rate in chips, carbonated drink, French fry, fried foods, etc. is 1,400%, almost 100 times. You see, if you believe in stock market, Varun Beverages is a bottling unit and they are growing tremendously. Why? Because people are consuming lots of carbonated beverages. Coca-Cola is setting up 2 more factories. If you read Flavy Update, you must be knowing these things. Let us move to another future health issues. Constipation is very common as of now because there is no fiber content in the ultra processed food, and most of the ultra processed foods or say Horeca segment or say QSR, quick serving restaurant segment foods are high in gluten, be it a pizza, burger, hot dog, etc. Then comes an allergy. Allergy is mainly caused because of protein content, and we are consuming the complex protein containing food. The single food which contains soya base also, milk ingredients also, maybe some other proteins also. And that's why there are complex food matrix is responsible for complex allergy, and that's why there are certain diseases or there are certain illnesses or there are certain allergic symptoms which are not having any cure or say, treatment. Gut health related issues. We do not feel a premium, we do not feel a specialized when we drink lassi along with the pizza, but we consume carbonated drink along with the pizza and burger. So this is where the real issues start. Fermented foods are very much less in our day-to-day diet, and out of that, even prebiotic containing foods are not included in our common day-to-day diet. We are constantly observing that nowadays heart attacks and heart-related issues are very common at young age of 35, 40, even in Delhi around 30, because we consume highly unbalanced fat profile. We are consuming a palm fat-based or say a palm stearin-based fried foods like say, aloo tikki or highly stable foods under frying condition, palm oil or something like that, which are very much unstable because of very unbalanced because of very high saturated fat. Then diabetes at very young age, we are consuming lots of high fats and sugar consumption. So I'll not go into detail, but we must understand these things that because fat is gold for body always prefer fat to get deposited, and because of high fat absorption, body stops digesting the sugar, and that's where diabetes occurs. So diabetes is not because of high sugar consumption only, but diabetes is because of actually unbalanced fat or lipid metabolism in the body. And if we keep continuing the consuming the high fat product, the body will have a diabetes, body will stop digesting, stop metabolizing the sugar content, and we have a diabetes. Issue with the bone health also, like say less milk and fermented milk, because milk is the only source of calcium which is highest bioavailable in the body. Because we have a two system, one is a active absorption, another one is a passive absorption. Passive absorption occurs when calcium is bound with the serine residue of casein, as well as active absorption of calcium occurs in the presence of vitamin D. Milk is having both vitamin D with fat. Milk is having both protein also in form of casein. So milk is having the most bioavailable calcium content. But we have a less milk and fermented milk consumption. In fermented milk, there is one another advantage is that calcium is solubilized in the acidic condition, and fermented milk is having a lactic acid pH around 4.5, 4.6. So acidic calcium is more bioavailable. That's why we say that dahi hai wo doodh se savaya hai. Dahi is one step ahead or above than milk. Having a PDCAS value of actually 1.14 or say 1.04, but the scale is 1. It is a value of bioactive peptides. It is responsible for passive calcium absorption. Milk is loaded with the mineral, and mineral profile of milk is unique because if you consider the ratio of calcium and phosphorus in the milk, it is very much close to those ratios which are ideal for bone calcification, blood health, bone health, etc. Vitamins, vitamin A and D are there in the milk fat. So that's why we call fermented milk one step above milk nutrition. We will not go much into detail about milk fat, but yes, milk protein is very much important. Milk protein is having the complete nature's most complete protein along with the egg protein. It supplements and complements other vegan proteins when combined in the diet, because those therefore of research work has been carried out in the past, and all of them support that the milk bioactive peptides are having a diverse bioactives such as antioxidant, antimicrobial, antihypertensive. In fact, Dr. Srija in the previous session listed that by help of various starter cultures, the resultant fermented food had an antioxidant property or anti-hypertensive, etc., etc. But इन अवर ट्रेडिशन हम बच्चों को पहले से ही सोने से पहले वार्म मिल्क देते थे. So it was about opium activity. All right, so immunomodulatory, immunostimulant, antithrombotic, and there are so many bioactivities which are associated, well proven by bioactive peptides. Milk protein is also essential source of branched chain amino acids, which are alternative to ATP or say glucose for severe exercise and athletic performance. Now, whey proteins, basically alpha-lactalbumin and beta-lactalbumin, they are the richest source of branched chain amino acid, and this is why whey proteins are very much preferred for athletic performance and gymnastics. So these are certain bioactive peptides which are derived from the casein basically. So casein, as we know, there are 4 types of casein: alpha S1, alpha S2, beta, and kappa. And these are certain bioactive peptides which are generated from the casein, different casein fractions, and these are the bioactivities like say antihypertensive, opioid, antihypertensive, immunostimulant. Phosphopeptides carry minerals, calcium, and phosphate. Beta casein also gives immunomodulatory plus opium plus S inhibitory, and then antioxidative glycomacropeptide, which are generated during the renneting of milk during cheese making. It is also responsible for detoxification of the consumer or human body. Caseoplatin is also responsible for antithrombotic activity, and because of these things, we consider that fermented milks are nature's the best food and food for future generation. Apart from that, fermented milk is also termed as the best medium for probiotic and prebiotics. It is also best medium to having all nutrition compatibility other than vitamin B and C, water soluble based basically, and maybe iodine or iron content other than these vitamins. For fermented milk, milk is having a shelf life of 2 days or 3 days, but when you ferment the milk, we can have a shelf life up to 30 days in form of yogurt or fermented milk. I'm not talking about USC1 here, but if you make cheese, we can have a shelf life of several years also. I got cheese from USA and it was a 6-year-old cheddar cheese and it was awesome. Fermented milk can be having a shelf life up to several years also. The beauty of fermented milk is that you cannot consume in overload condition, or you cannot have a overdose of calories or any nutrients when you consume fermented milk. The one of the very important segment or important saline feature of ultra processed food is that you cannot control your consumption of ultra processed food, and this is where most of the time uncontrolled consumption of pizzas, burgers, french fries things happen. But this is not the I haven't heard, or probably nobody has ever heard that person consume 2 kgs of dahi or 1 kg of cheese at a time and they had an issue with the weight gain or something like this. Fermented food is pre-digested one, so because over the time digestibility and gut health is reducing or degrading day by day, fermented food will be, because it's a pre-digested one, it's food for the future. Now let us focus on again, what are the future health issues and how fermented food will help. Say for example, acidity and indigestion. Milk protein is having a high buffering capacity. In fact, one of the students from SMC College of Dairy Science had done his master degree, Dr. Ankit Hesha from India, Karnal, and he worked on the manufacturing of antacid from milk. So this is where milk protein comes into the picture. Milk protein is having the buffering capacity and gives instant relieving from acidity and indigestion. Constipation. So if you or any consumer is having a constipation related issue, he or she should start consuming prebiotic or say fiber enriched dahi, at least 200 gram or 300 gram in his or her daily diet, and they will have a better gut health. For allergenicity, milk protein is hydrolyzed or digested in form of dahi or say cheese, and allergenicity is addressed to the greater extent. If anyone is having a health related issues, then fermented food is the only one who supplements the starter cultures and probiotic. Those bacteria starter cultures get colonized in the human gut and they have a better health. Like for diabetes and heart related issues, we have discussed, we have had several names of bioactive peptides. For bone health, calcification is very much essential, but we do not have sufficient fermented food in our day-to-day diet, so we should incorporate higher calcium containing fermented milks in our day-to-day diet. So dahi or buttermilk should be a routine part of diet, and we will have a better bone calcification. Certain respiratory health issues can also be addressed with the bioactive peptides. In fact, certain colostrum-based bioactive peptides and certain fermented milk-based bioactive peptides provide great health benefits against respiratory health issues. There are certain research and facts related to fermented milks, and we say that all the previous health claims are already proven actually. Traditionally, milk, dahi, and ghee are 3 of 5 panchamrit. Other than these are one is sharkara, shakkar, and say honey or shahad. So we must understand these things that out of these 3, milk, dahi, and ghee, 3 of 5 panchamrit are from milk. Out of these 3, 2 are fermented milk. I'll tell you, dahi is classically a fermented milk, basically, or fermented milk fat. So dahi and ghee both are fermented milk products. So out of 5 panchamrits, 2 are based on fermentation. Dahi is having excellent activity against stomach upset. It cools down angers and body as well as protect from heat shock during the summer. तो इसीलिए पहले जमाने में जब हम कहीं बाहर जाते थे तो मम्मी बोलते थे एक चम्मच दही खा के जाओ, वो इंस्टेंट इफेक्ट देता है बिकॉज ऑफ बायोएक्टिव पेप्टाइड. If we compare buttermilk versus carbonated soft drink, we must understand that buttermilk replenish the water and mineral loss due to sweetening in our body because buttermilk contains around 5% DS and 95% water. But remember, there are certain issues with the fermented milk also that needs to be taken care. The excessively sour fermented milk, which are having acidity of more than 1%, is not advisable. Okay, because sometimes contaminants also produce D-lactic acid, which is enantiomer of lactic acid, which is harmful basically. So the ideal fermented milk having around 0.7, 0.8 or maximum 1% lactic acid is advisable. Over excessively sour fermented, uncontrolled fermented milk is not advised. Improper hygiene may cause food poisoning because we know milk is a complete food, milk is a best source for microbes to grow. And if fermented milks are not manufactured in the hygienic area, food poisoning chances are very much. Sometimes manufacturers add excessive preservatives to control bulging or KS or coliform growth, which are also not good. They will harm us in both the ways. Thermal processing of fermented milks extend the shelf life to reduce the bacterial load. But remember, we are not getting sufficient prebiotic or sufficient probiotic or starter culture, which are beneficial our gut health also. So, and the most important issue with the fermented milk is that fermented milk like buttermilk or dahi or cheese, they do not gel well with the ultra processed food. Nobody consumes fermented milk with ultra processed food. Hence, they are never in the menu of HoReCa segment. आप कोई भी ब्रांड का HoReCa सेगमेंट विजिट कर लो, आपको मेन्यू में बटर मिल्क या दही नहीं मिलेगा. आपको कार्बोनेटेड बीवरेज में आपको सारे वेरिएंट मिलेंगे. पेप्सी है, कोक है, थम्स अप है, स्प्राइट है, लिम्का है, मिरिंडा है, सब मिलेगा. लेकिन बटर मिल्क में आपको अगर मिलेगा तो भी प्लेन बटर मिल्क होगा. नोबडी से कि बटर मिल्क के भी वेरिएंट्स है. सो दिस इज द बिगेस्ट इश्यू. Now, I'll give you a classical example of case study. This is my client, Mr. Ragelos from the Europe. He's a Cyprian guy. and they are basically he's having 4 brothers and sisters. So they are 5 basically, and many of them, the family members were having diabetes and certain blood pressure related issues. When I went to Europe, I recommended him that you should start focusing on fermented milk, start consuming yogurt on a daily basis, and stop consuming high-fat food. And after 6 months, he called me that Sanket, everybody in my family is having much better result after consuming the fermented milk. In fact, people stop consuming the pills for high blood pressure. Basically, they consume lot of high salted food such as halloumi cheese or something like that, which are having a very high salt content, and that's why they had a high blood pressure. But the moment they started consuming more of dahi, they had a better result. And this is about the last slide. For a healthy diet, 1/3 of our diet should have should be made up of or should of fruits and vegetables of fresh in nature without any processing. Another 1/3 should be our staple food like roti, chapati, or say rice, chawal, or biryani, whatsoever we say. Remaining 1/3 should be focused on the proteins and minerals, maybe milk and milk product, cheese, meat, fish, egg, etc., beans. If somebody is vegetarian, the 33% should be of milk, cheese, dahi, yogurt, etc., buttermilk, etc. If we want to go with the product which are having a high fat, sugar, or maybe ultra processed food, this should be less than 10%. Maybe once in a week we can go. So this is about the scenario of ultra processed food and where future of fermented food lies. That's it. Jai Hind, Jai Bharat. Thank you.
Thank you so much, Dr. Sanket, for explaining about the health issue we are going to face in near future due to consumption of ultra processed foods and role of fermented food in mitigating the health issue we are going to face due to ultra processed food pattern. So I request all the participants to kindly write your queries in the chat box. We'll answer all the questions during open discussion session. Moving ahead, our next speaker is Dr. Neerja Hajela. Madam is Secretary of Gut Microbiota and Probiotic Science Foundation, New Delhi. I invite Dr. Neerja for delivering her talk on the topic probiotics, criteria, mechanism, and clinical evidence.
Thank you so much. Can you just share, help me share my screen? If you can make me the presenter, please.
Dr. Sujit, kindly.
Yes, ma'am, I've made you the present already, and your screen is visible to us. You can turn on your presentation. Yes, your desktop screen is visible to us.
How does it? Can you make me the presenter?
Yes, ma'am. Yeah, you're the present already. I've made you the presenter. Ma'am, webinar में मैं phone करता हूँ.
Can you see my screen?
No, madam.
No, madam, please
No, madam.
share your screen. Your desktop screen is visible, but you share the PPT. And now it is coming. You make a full screen.
Yeah, we can see your slides. You just make it in a slideshow mode. Yes, perfect. Perfect.
Okay. I see. Can you see the slides?
Yes, ma'am. Yes, we can see.
Okay. So, a very good morning. And at the very outset, I would like to thank all the dignitaries, Professor Prajapati, Dr. Subrata Hati, and all the senior dignitaries who have invited me for this presentation. It's a real pleasure and privilege, and I'll be talking about probiotics, criteria, mechanisms, and clinical evidence. So the outline of my presentation is as under. So I'll be basically giving a background of for the reason for probiotics, their criteria, mechanism, clinical evidence, and the take home. So we all know that the new era has dawned in medical science, and the past decade has provided some very phenomenal insights into fascinating facts that we harbor almost the same number of microbes as human cells. And these microbes inhabit every part of the human body, including the intrauterine environment, which was initially believed to be sterile. So, these microbes, in terms of genetic composition, they are 150 times the genetic composition of the human genome. And like I said, they are found in every part of the human body. But the largest number of these microbes, bacteria, viruses, fungi, they are found in the gut, the intestine. So as you can see here, the number of microbes, they differ in different parts of the digestive system simply because there are differences in pH, transit time, substrate availability, and also because of different types of pH in the different parts of the intestine. And as you can see here, the colon has the largest number of these microbes. It's almost 10 to the power 10 to 10 to the power 12 colony forming unit per ml of the colonic content. Now, the next question is, what are these microbes doing there in the gut? It's such a large number of these microorganisms. So, they have very essential functions. Basically, your digestive system and your immunity cannot function without these microbes. So, they exert protective, structural, and metabolic functions. And they are your first line of defense against pathogens, and they inhibit their proliferation by competing for nutrients, by competing for receptor spaces on the intestinal epithelium, and also by producing antimicrobial factors such as bacteriocins and lactic acid. Most importantly, these microorganisms ensure barrier fortification. They induce the production of secretory IgA. Secretory IgA, as we all know, is the largest produced antibody. It's present in the mucosal linings, in all the mucosal lining, and is your first point of defense against bacterial pathogens and toxins. Now, another important role that these microbes exert is that they help in ensuring the integrity of the intestinal barrier, and they do this by upregulation of tight junction proteins. They also provide signals for proper development of the immune cells, and they help in the growth and maturation of the innate and acquired immune responses. Now, another important function is metabolic function, where these microbes help in digestion of foods like your resistant starch, your polysaccharides, your fibers, which cannot be digested by the enzymes of the human body. So when they do that, they convert these foods into what is known as short-chain fatty acids. And these short-chain fatty acids then play a very, very important role in ensuring gut motility, reducing the pH of the intestinal lumen, and ensuring proper absorption of magnesium, calcium, iron. And many of these microbes can actually synthesize vitamins, particularly biotin, folate, and vitamin K in the intestine. So as you can see here, so as you can see here, in their native state, when the balance of the good and the bad bacteria in the intestine is maintained, they encode key functionalities. Like I said, they have metabolic function, they help in synthesis of amino acids, vitamins, help in immune maturation, modulate your nerve functions. We all know about the gut-brain axis, and they help in resistance to pathogens. But these gut bacteria in the intestine, they are not stable. They are dynamic and constantly change because of exposure to antibiotics, high-fat diet, alcohol, lifestyle, hygiene, immune deficiency. And when that happens, there is an imbalance in the gut microbiota, which is also termed as gut dysbiosis. And this gut dysbiosis is linked to several disease conditions: obesity, type 2 diabetes, colorectal cancer. Almost 25 different disorders have been linked to the imbalance of the intestinal flora. And this is a chicken and egg situation. We do not know which came first, whether the dysbiosis was linked to disease or the other way around. But nevertheless, there is a clear link between an imbalance of the gut microbiota with different disease conditions. Now, like I said, there are dysbiosis, but there are two types of dysbiosis. One could be at a taxonomic level. So there is an imbalance of microbial species composition at different taxonomic levels like the phylum, class, genus, or even species. And there is another functional dysbiosis where the composition may not change too much, but there is a difference in the level of microbial metabolites in the intestine or the blood, which is very, very distinct between healthy subjects and patients. And the consequences of this disbalance or imbalance or the gut dysbiosis is what is already reflected in this slide. So now the next question is that how do we modulate the gut microbiota to increase the beneficial components and decrease the harmful disease-causing organisms? So we all have heard about fecal microbiota transplant, which is nothing but transplanting the fecal microbiota from a healthy donor to a diseased recipient. And this has been used very effectively for treatment of recurrent Clostridium difficile infection. So this was a meta-analysis of 574 studies, 8 different randomized controlled trials, where they showed that the incidence of recurrent diarrhea in C. diff patients was only 11% when they used FMT, as against 24% when conventional treatment was used. So this just tells us the power of replenishing beneficial bacteria for treatment of diseases. And therefore, we have several interventions for modulating the microbiota. You have targeted interventions like drugs, bacteriophage therapy, and you have untargeted interventions like diet, exercise, probiotics, prebiotics. Now, we are also hearing about postbiotics and fecal microbiota transplants. So we have heard a lot about fermented milk in the previous two talks, about lactic acid bacteria, about starter cultures. But probiotics are lactic acid bacteria, but not all lactic acid bacteria are probiotic. Simply because there is a definition which has been given for probiotics by the Food Agriculture Organization and World Health Organization. And they define probiotics as live microorganisms which, when administered in adequate amounts, confer a health benefit on the host. So for any organism to classify as a probiotic, it is very, very important that that particular organism is identified to the strain level. So genus, species, and strain to be identified by phenotypic and genotypic methods. The probiotic strain needs to be deposited in an internationally recognized collection center. Then the probiotic strain is screened for in vitro tests like tolerance to gastric juices, to bile, and also it is tested in vitro for its ability to transit the GI tract and reach the target site alive in large numbers. And then you have in vivo studies, which are in animal models. You have safety studies where you test for acute, subacute, and toxic levels of that same probiotic and for the safety in an animal model. Then the health benefit of that particular probiotic is tested in an animal model. And then you come to human studies where they are tested in phase 1 for safety, phase 2 for efficacy, and phase 3 for effectiveness. So as safety, the probiotic strains normally have a GRAS status, generally recognized as safe, and they're tested for their inability to transfer antibiotic resistance and production of any toxin. Efficacy, the health benefit is normally evaluated in a randomized controlled trial. And normally for probiotics which are found in food, you do not do the effectiveness studies. And then once you have a probiotic strain, you formulate it into a probiotic food, which is then labeled as under, where you give the genus, the species, the strain. You give the minimal viable number of probiotics at the level at which efficacy is claimed at the end of shelf life. So most often what happens is many probiotic foods have the required number of organisms at the time of manufacture, but when you come towards the expiry date, you see that the numbers have declined. So obviously you're not going to get the health benefit that that product is claiming. Then the health claims and serving size for efficacy and the storage conditions. So now probiotic mechanisms of action. So it appears that there is a tri-directional communication between the host, between the colonizing microbes and the probiotics. So most importantly, these probiotic bacteria, they must reach your intestine alive in very large numbers, and therefore they have to tolerate the harsh, conditions of the stomach and bile and all of that. And once they are in the intestine, they tend to compete for nutrients with the colonizing bacteria. Another important way in which they act is they improve your barrier function, and they do that by increasing the thickness of the mucosal layer. The mucosal layer is what keeps the microbial communities at a safe distance from the intestinal epithelial cells. So they do this by production of mucin. They support the upregulate tight junction proteins and support epithelial cell health. Then it is the surface proteins or the surface structures like lipopolysaccharide, lipotecoic acids, which are actually the drivers of the probiotic health effects. So what you have is these surface structures are then recognized by toll like receptors, and they impart their benefit. And what is very, very interesting is that many of these probiotic bacteria can actually manufacture neurochemicals like cortisol, serotonin, gamma aminobutyric acid, tryptophan in the intestine. They also produce enzymes like bile salt hydrolase, lactase, which help in digestion of your lactose and other compounds. And like I said, they help in modulating the immune system, they upregulate antibody response, they downregulate inflammation, and also stimulate phagocytosis. So, and bacteria like probiotics, which are most common are lactobacillus and bifidobacteria, what they do is they produce organic acids like lactate and acetate, which reduces colonic pH, and they produce butyrate through cross feeding. So, like I said, there is a tri-directional communication, and one probiotic strain may actually impart more than one benefit. This is a very complicated slide, but nevertheless, these probiotics, how they manage or the microbiota mediate immune modulation. They do this by T regulatory cell induction. And then you have segmented filamentous bacteria, which can produce Th17. And Th17 is plays a beneficial role, particularly during enteropathogenic infection with Salmonella enterica and Klebsiella pneumoniae. Then you have intraepithelial lymphocyte induction. You have natural killer cells. NK cells, as the name suggests, are your first line of defense against tumors and viruses. So, for instance, the lipopolysaccharide peptidoglycan complex in Lactobacillus casei shirota increases the NK cell activity, and this is effective against tumors and viral infections. Then they help in the production of CD8 T cell induction, B cell modulation by increasing production of IgA, dendritic cell modulation, and macrophage modulation. Now, many of these probiotic bacteria can actually, sense the situation and thereby, induce the production of pro-inflammatory or anti-inflammatory cytokines to ensure the balance of the immune system. And they have different types of effects. They have effect of the microbiota on anti-cancer immunity. They upregulate production of antibodies, and they can also induce your innate immune system by production of lymphocytes. So there's a large amount of clinical data which has gathered over the last decade on the benefits of probiotics. And if you were to do a quick PubMed search, there are more than 8,000 publications which you will find as of date. So now if you look at the targets for probiotic benefits, it is infants, children, and adults. And these indications which have been highlighted in bold are the ones where you have the maximum amount of data. So in infants, it is for necrotizing enterocolitis. In children, you have acute infectious diarrhea, antibiotic-associated diarrhea, lactose maldigestion. And in adults, including the elderly, there's a lot of data which suggests benefits of probiotics in antibiotic-associated diarrhea, pouchitis, and lactose maldigestion. But we must remember here that probiotic benefits are strain-specific, so no two probiotics are going to impart the same health benefit. So this is a landmark paper which was published in PLOS One, and this is basically a meta-analysis of 84 randomized control trials, which included 10,000 more than 10,000 subjects. And the benefit of different strains of probiotics was tested in 8 different GI disorders. So pouchitis, infectious diarrhea, irritable bowel syndrome, H. pylori, antibiotic-associated diarrhea. So 8 different GI disorders. While there was a lot of heterogeneity when it came to the age of the subjects, the dose of the probiotic, length of treatment, and also the type of probiotics which were used, single versus multiple species. But the conclusion of this particular meta-analysis was that probiotics had a positive, significant effect across all 8 GI disorders. Now, in the perinatal and infant period, there have been studies which have shown that probiotics are a safe alternative in pregnancy and in full-term newborns. And they have wide application throughout perinatal life, but it is still imperative to perform rigorous studies and enact regulations to guarantee the safety of the weakest population. Now, in post-operative infectious complications, what has been seen is that most often when you undergo a transplant or a surgery, while the surgery may have been totally successful, but most often you come down with post-operative infectious complications. So I'm just talking about one study which had 52 patients with biliary cancer, of which 44 completed the study. And they were fed a symbiotic preparation post-operatively through enteral feeding. And what was observed was that the number of beneficial bacteria in the symbiotic group significantly increased after treatment with the symbiotic, whereas the beneficial bacteria decreased in the control, and there was an increase in the harmful pathogenic bacteria, which then cause infections. And then again, there is a need for antibiotics. There is more days that you need to spend in the hospital, and that leads to several complications. Also, if you look at the total organic acid concentration, it increased in the symbiotic group but decreased in the control. And if you can look at this finding, it shows that the infectious complications were only 19% in the symbiotic group, infectious complications, and 52% in the control group. That is, out of 23 people, 12 of them had infectious complications. So this study suggests that symbiotics, when combined with early enteral nutrition, can reduce post-operative infectious complications. Then during the COVID time, there was a lot of talk about the link between the gut and the lungs, because viral nucleic acids were found in the fecal samples and in the anal swabs of patients with COVID-19. And ACE2 receptor, which is the binding domain of COVID-19, was abundant in the lungs as well as in the gut, suggesting a gut-lung crosstalk. And patients with respiratory infections during COVID-19, they generally had some sort of gut dysfunction. And it's not surprising that China's National Health Commission then suggested the use of probiotics to COVID-19 patients to maintain the balance of the intestinal microbiota and prevent secondary bacterial infections. Now, I come to some two interesting India studies, and we all know that today we are grappling with the triple burden of nutrition, and malnutrition is a huge concern in our country, especially undernourishment. So this is one study which was published in Epidemiology Infection. It is a large community-based study which evaluated the role of a probiotic in preventing acute diarrhea in children. And as you can see here, these are the pictures of the study. You can see these are slum children. They were in the age group of 1 to 5 years. And this is a double-blind randomized controlled trial where 3,758 children were divided into two groups. One was the probiotic group with 1,894 children, and the other was the nutrient group with 1,864 children. So they were given a probiotic drink for a period of 12 weeks, and the other group got a nutrient drink without the probiotic bacteria for 12 weeks. They were then followed up for another 12 weeks, and at the end of 24 weeks, the children in the probiotic group there were 608 children with diarrhea, which is 0.88 cases per child per year, whereas there were 674 children who had diarrhea in the placebo group. That is 1.029 cases per child per year. And if you look at the enteric pathogens, the viruses, the parasites, and the bacteria, there was not much difference between the two groups, except for Aeromonas as well as Cryptosporidium, which was which was increased in the nutrient group as compared to the probiotic group. But nevertheless, this probiotic showed that there was the consumption of a probiotic for a period of 12 weeks in a slum setting imparted a protective efficacy of 14% when it came to prevention of acute diarrhea in these children. And this was a significant finding, given that it was only a 12-week study, and it was just 6.5 billion of the probiotic strain which was used. Probably, if the dose had been increased or the study had been for a longer duration, the benefit could have been quite different. But however, the study did suggest that daily intake of a probiotic drink can play a role in prevention of acute diarrhea in a community setting of a developing country. Then this is another very interesting study which was published in Nature. It is a study which evaluated the role of a symbiotic to prevent sepsis among infants in rural India. So as you can see here, there was a probiotic strain which was used, which was Lactobacillus plantarum, ATCC strain 202195, and fructooligosaccharides. So as we all know that neonatal sepsis is a major cause of morbidity and mortality in neonates, especially in developing countries, with fatality rates as high as 5 to 60%, even with antibiotic treatment. Now, this study was conducted in 149 villages of Odisha, and it is again a large community-based, double-blind, placebo-controlled, randomized trial. And this basically evaluated the incidence of neonatal sepsis in neonates. So the neonates were at least 2,000 grams in weight, and they were at least 35 weeks gestation, and they had no signs of sepsis or any other morbidity. So this is a study of Professor Pinaki. This is a picture of Professor Pinaki Panigrahi, who conducted the study, and this is the condition of the neonates. This will also help you get an idea of the kind of subjects who were used in this particular study. So at the beginning, 789 births were screened in the study villages, of which 4,556, that is 64%, were enrolled in the study. 2,278 neonates were, basically recruited in the symbiotic arm, and the remaining 2,278 neonates were in the placebo arm. All infants and maternal variables were distributed similarly between the placebo and the treatment group, and the symbiotic Lactobacillus plantarum and fructooligosaccharides was selected because of its ability to colonize for more than 4 months and was administered orally to the newborns for 7 days, beginning 2 to 4 days of life or 24 to 36 hour window period. The neonates were monitored for a period of 60 days, and all suspected cases of sepsis and other adverse events and severe adverse events were managed by study physicians at the attached hospitals. Of the 4,556 neonates, 319 neonates recorded as sepsis according to the WHO criteria by the physician. Now, if you look at the primary outcome and secondary outcome, there was significant reduction in the primary combined outcome of neonatal sepsis from 9% in the placebo arm to 5.4% in the treatment arm, and this resulted in a 40% reduction of neonatal sepsis. Each of the 3 components, which is culture positive sepsis, gram positive reduced by 82%, gram negative reduced by 75%, and culture negative sepsis reduced by 47%. When you look at the secondary outcome, there was a reduction of 34% in the symbiotic group in lower respiratory tract infections, and local infections, which were 1% in all the infants, reduced by 52% in the symbiotic arm. And at 60 days, there was greater increase in weight since birth compared to the placebo group. So this study also summarized that there was benefit of the symbiotic in reduction of neonatal sepsis in healthy neonates in India. There was significant reduction in lower respiratory tract infection, as important as prevention of clinical or culture positive sepsis. There was substantial reduction in variety of other infections, which was the value of this particular intervention. And the number needed to treat of 27, the investment to prevent one case of sepsis was only USD 27. Then this is another very interesting meta-analysis, which basically was conducted to evaluate whether a probiotic supplementation compared to a placebo could reduce the use of antibiotics in a group of children and adults who had different types of infections. We all know that today we are in a stage where antimicrobial resistance is a huge concern, and there are the WHO and all other organizations are looking at newer intervention which can be used to prevent disease and thereby reduce the use of antibiotics. So this was again a systematic review of 17 randomized control trials for infants and children, and they were used for to evaluate the benefit of a probiotic in preventing acute respiratory tract infections, acute lower digestive tract infections, and also otitis media. There were 13 different probiotic formulations, some single, some combination, but using lactobacillus and bifidobacteria. And the duration of the supplementation was 4 days to about 9 months. And the meta-analysis concluded that infants and children who received probiotics to prevent acute illness had a lower risk of being prescribed antibiotics relative to those who received the placebo. So today, given the kind of scientific data which has gathered for the benefits of probiotics, but again, I mentioned that probiotic benefits are strain specific and no two probiotics are going to give you the same benefits. So there are recommendations for the use of probiotics. So SPAN has brought out a position paper for use of probiotics and prebiotics. The World Gastroenterology Organization, they have come out with new guidelines in 2023. This is slightly dated, but that those actually indicate the different species and strains of probiotics which can be used for different disease conditions. Then you have World Allergy Organization, which have brought out guidelines for the use of probiotics during pregnancy and in newborns for reducing the risk of allergies and other infections. So probiotics can be used very, very effectively to prevent antibiotic resistance or antimicrobial resistance, because there is a clear association of microbiome alterations with the progression from health to disease. But what we need today to really drive the science is definition of validated markers to be advanced, the benefit of probiotic inducted microbiome changes to be verified. Probiotic benefits are strain specific, therefore, it is very important to elucidate the mechanism of action of different strains of probiotics and determine which organism is most likely to provide a benefit for a particular condition. So, I think going forward, a mechanistic based approach coupled with carefully conducted multi center randomized control trials will elucidate or will ensure the potential of probiotics as an alternative management option for various disease conditions. And I end with this quote that the enemy of my enemy is my friend. If we have to limit the use of antibiotics, we will have to use different interventions which can help in reducing risk of infections and thereby reduce the need for antibiotics. So with that, I end my presentation and I'll be very happy to take any questions that you all have.
Thank you, Nirja ma'am, for your detailed presentation on probiotics. What are the criteria which are required for claiming a strain is probiotic, different mechanisms they conferred, and you also shared many latest clinical evidence which proves the health benefit due to consumption of probiotic food. It was really very informative presentation. Thank you. Thank you so much, madam. I request all the participants to paste your questions in chat box. We'll answer at the end of webinar. And there is one announcement for all the participants. There is a feedback link pasted on both the platforms. Go to webinar and YouTube. Kindly click on the feedback link and you'll get e-certificate. Once you fill the feedback form, you'll also get e-certificate on your mail. Now it's time for the open discussion and concluding remarks. I request all the three eminent speakers to switch on your video. And I request Dr. J.B. Prajapati sir, retired principal and dean of our college, chairman of Indian Dairy Association West Zone, and coordinator of Swedish South Asian Network on Fermented Foods, to conduct the session. I also request Dr. Sujit to share the questions with the J.B. Prajapati sir. Over to you, sir.
Thank you, Dr. Mittal. I could not see Dr. Nirja. Dr. Nirja, are you there?
Stop sharing नहीं कर पा रहे
हाँ.
अभी कर रहे हैं लगता है
एक और किसी की आवाज आ रही है? So it was a nice session today with yes, welcome Dr. Nirja. Happy to see your face today morning.
Nirja
Maybe
ma'am, we are seeing your mail on the screen. You stop sharing. You click on the
stop.
stop sharing.
So we had a very good dose of research work done in the area of probiotics and fermented foods, and also added with a flavor of ultra processed foods too. We started with Dr. Srija, starting with the basics of starter cultures, and then she has taken to the latest research being done at SMC College of Dairy Science. As all of you know well, that we are working on probiotics and healthy bacteria, lactic acid bacteria, since 1980. So now it is more than 44 years. And Dr. Srija, Dr. Subrato, Dr. Mittal, they are carrying forward the legacy of probiotic lab from Anand. She has also presented something on bioactive peptides as well as vitamin synthesis, as well as some of the uses of the fermented foods developed by the laboratory in clinical applications, including the human as well as animal trials. Dr. Sanket Borad is a well-renowned technologist, and he had given basic differences between different types of foods, and then he just drew our attention to the highly processed foods where our new generation is getting diverted and getting addicted to. So in this era of this kind of foods, how the fermented foods can help to take care of some of the common problems, and the health benefits have been discussed by him. While Dr. Nirja is the head of science at Yakult, and she delivered what was expected from her. She has gathered many clinical trials across the world, lot of work on Lactobacillus casei and many other strains, and she has touched typically on gut microflora and all the ailments which have been tested and tried to be resolved or down regulated with the use of specific probiotic strains. So we'll take the questions directly from the panel first to the speakers, and then Dr. Sujit will read the question from the chat box for typical address to a particular speaker. So any question, please speak out your name and to whom you are addressing.
Hello, can you hear me?
Yes, please. Yeah.
Yes.
Yeah, this is Sailesh from Fab Nutriment Foods Private Limited. And first of all, I would like to thank FIRAC for organizing this wonderful session. And I'm a big grantee also for the development of the probiotic millet-based beverage, which I'm looking to commercialize it. So, with regards to this, I have a few questions which I will ask one by one. The first question is to Dr. Nirja ma'am. these most of the probiotics are available in as a powder form. The strains, whatever the approved strains by the FSSAI, the lactobacillus and everything, there are total 14 strains approved by FSSAI, and they are available as the probiotic powders. My first question is whether taking these powders will, I mean, whether they should pass through the GI tract, right? Whether this the particular strain will be available and it alter the gut microbiota. That is the first question. By just dissolving simply the powder into the water or whatever medium, and if you can take it, whether it will take, it will give the desired effect. That is the first question. And the second question is the duration of taking this probiotic powder. On an average, how much time should we recommend to the consumers for taking this probiotic formulation to show the desired effects? And the third question regarding the efficacy testing of the probiotic products. If we can say that by just by testing the stool after before and after taking the stool of this probiotic, the microbiota. So the stool is the only thing we can check for this microbiota, as per my knowledge. Are there any specific tests to measure this efficacy of that gut microbiota? Please throw some light on that also, so that it will be very helpful to me. And the fourth one is the in vitro test that can be carried out for studying this efficacy of this particular formulation of the probiotic bacteria. That's it from my side. And there are more questions. These questions to falling to the Neeraj ma'am, so that I can go forward with other questions to other speakers, panel speakers.
Please unmute yourself, Dr. Nirja.
Yes, I was
Ma'am, you're
muted
unmuted. You
by-
can speak. Yeah.
Yes, I was muted. So basically, your questions are many. So the first question is that you're saying that these probiotic strains are available as a lyophilized powdered preparation, right? So
Yes,
yes, available as a powdered preparation, and the powder is declaring the complete name of the probiotic, the genus, the species, the strain, the numbers of the probiotic strain. Then it classifies as a probiotic, and these probiotic strains have been tested for their ability to survive in the GI tract and reach the target site, whether it is the terminal ileum or the colon, but they have been tested to reach the target site and impart a health benefit. So, whatever the formulation may be, whether it is a powder, whether it is a curd, whether it is a fermented milk, any formulation which states that it is a probiotic will have to will has to ensure that those bacteria reach your intestine alive. That is one.
that is what, ma'am. Yeah. One thing, ma'am. Here is the crux. That is there are available also probiotic lyophilized powders. But what test clearly signifies that it is going to be resistant to the acid in the stomach? What
So
test that will determine it? Whether
yeah,
it is
so
through the testing the stool or any in vitro test is available to test it. Because being a, I want, yeah, just a minute. I want to commercialize it. Just I want to fortify my product with this lyophilized powders of the probiotic strains. So before accepting that lyophilized powder, what test should I ensure? Should I make or should do to ensure that it is crossing the gut? I mean the stomach.
So basically, what you have, Dr. Prajapati, you can correct me if I'm wrong, but I think what you need to do is you need to do a basic testing of the product has to be done on the media which has been suggested for that particular probiotic strain. So that can be done.
That gives the CFA colony forming units or the as per the claim. Maybe it may be 10
Absolutely,
or 10 power.
absolutely. And
I
then
think,
you need to do a
Dr.
fecal flora
Nirja,
analysis. You need to do a
just let
fecal
me.
flora.
Hello. Actually, Mr. Sailesh, there are in vitro tests specified in the ICMR DBT guidelines that these tests must be done before you go for other kind of trials with mice or with human being. So at least the basic requirements of acid tolerance, bile tolerance, pH, lysozyme, and probably there are few more tests, but 6 or 7 tests. These tests
Yes.
must be passed by the strain which you want to test and make convert into powder also. And probably there may be some mutations during when it is converted into powder form, and hence the final product has to be again tested for the same tests which you have done with this strain. So this is the what is requirement as per the guidelines. Yes, Dr. Nirja, please. Sorry to interrupt.
How do we know that it has reached your intestine alive? I think that's what he wants to know, that while you can test it when it is a product, but then how do you know that it has actually transited the GI tract?
Correct.
So basically,
Correct.
I
Correct.
think you do the fecal microbiota, testing, and you test for the strain of the bacteria in the fecal sample. And normally what happens is, suppose you are saying that you have this product as 10 to the power 9 CFU, then we normally void about 100 grams of the feces. So you should get a minimum of 10 to the power 7 CFU per gram of the feces to know that it has actually transited the GI tract and has reached the...
Okay. You mean to say that if I add around 10 power 12 CFU colony forming units and fortify my product, and if I test with the fecus, that should be the minimum of the 10 power 5 or 7, around something like that, so that I can ensure that some has been died in the stomach, enteric stomach, and some benefit has been happened, right?
Yes.
Yeah, and what about the duration of the, how should the duration of the, intake of the probiotic powder?
Yeah, so probiotics are basically transient colonizers. So when you consume a probiotic, it does not become a part or an established part of your gut microbiota. So they grow for
Okay.
some time, and then they get passed out with the feces. So it's very important that when you're doing when you're taking a probiotic, regular consumption becomes important. Any probiotic, I'm not talking for any particular
No,
strain.
just to become, yes, I understood. Just because on average, how much duration can we take? Say for at least 3 to 4 months the consumer. Because if I am making it into a product, I should tell to the consumer that to feel the effect of this product, you should take a minimum of about 3 months or 4 months like that.
Yes.
Okay, anyway, I agree that there is no standard guideline, but
The
Mr.
benefit of the
Shailesh,
probiotics
please allow
varies from
the
person to
speaker to
person,
speak first.
So the
Okay.
benefit of the probiotic also varies from person to person, depending on so many other different, host factors and your environment, genetics, all of that plays a role. But a minimum of 1 month is needed for you to start seeing the benefit of the probiotic. So it's not a treatment, it's not a drug. You take an antibiotic for 7 days, you know that you have killed all those bacteria and you've kind of. But here it is a very, very slow process. So you require a minimum of 1 month for the probiotic for the person to start, understanding the benefits of that particular probiotic.
okay. And one more thing, if I can make both the prebiotic and probiotic into a single product, can I claim that as a symbiotic, like the fructose and any probiotics
You
claim
can,
into
but you need to see
one
the
product?
synergistic. Yes, but you need to see the synergistic effect of this probiotic and the prebiotic. So we can add multiple probiotics, multiple prebiotics to a particular product. But individually, what benefit it gives you and the synergy of both of them and what benefit it really gives you is very, very important. So whatever claim you're making on the product, obviously, if you're making a probiotic or prebiotic, you will make a claim on the product. So whatever claim you're making on the product, you have to very, very clearly mention that claim basis the synergistic effect of the pro and prebiotic.
Okay, so that it can be a symbiotic.
It can be a symbiotic, yes.
Okay. And one more thing, this question is thank you, ma'am. Thank you. Hello.
Mr. Shailesh, please wait. Let Dr. Prajapati speak. Please wait.
Yeah.
Okay.
Dr. Sujit, you may be having many questions in the chat box.
Right, sir.
Before
Right,
start,
sir.
I have one question for Dr. Nirja.
Yes,
It is in connection to yesterday's question. that what are the regulatory requirements for the products which are being sold as ingredients or the supplements or probably as a pharma products from the pharmaceutical stores or so? Because for the liquid or fresh products, food products, we have FSSAI that we know, and the requirement is 10 to 8 per serving size or so. But what about those dried products which are being sold in capsules and tablets and maybe powder form?
So, Dr. Prajapati, if they are being sold even as supplements and they come under the FSSAI nutraceutical regulation, then again, FSSAI has listed out 31 different species of bacteria with the new taxonomic names, and then these can be used as probiotics, and they have to basically mention very clearly the strain of bacteria, the viable count. Like for FSSAI, it is 10 to the power 8 per recommended serving size per day, 10 to the power 8 CFU in a product. And they have to mention the scientifically proven health benefits. But if something is being marketed as a drug, which does not come under the ambit of an FSSAI regulation, then it has to go through the drug authority and get all those, because then you are basically making a claim that it helps to treat a particular disease. So when a product is in a food formulation, whether it's a nutraceutical or any which thing, then you cannot use words like prevent, treat, alleviate, or mitigate. These words cannot be used for a claim. So then the regulatory requirements are very, very different.
I think this makes it clear. Even yesterday's questions.
Prajapati sir.
Yes, please.
Prajapati sir, Principal of SMC College of Dairy Science, Dr. Atanu Jana wants to share some of his experience regarding probiotics for the pet animals. So I'm inviting him, sir.
Yes, Dr. Jana, welcome.
Good afternoon to all, and my salutations to Dr. J.B. Prajapati, all the BIREC organizers and the learned speakers. Well, I wanted to share one incident with my pet dog, 3 years old now. Since birth, it is there with me. And Dr. D.B. Patil, our Honorable Director of Research and Dean PG Studies, is a very good veterinary surgeon. Same with our Vice Chancellor also, Dr. Kelawala. So Dr. Patil had sent one probiotic for its evaluation regarding the probiotic potential. And after he had analyzed that particular probiotic powder, Dr. Patil told him, give it to Dr. Jana because he has got a pet. So I started giving him that. It's more than 500 grams every day with buttermilk. At that time, it was not probiotic. Nowadays, we are getting probiotic buttermilk as well from Amul. So I used to add that, keep it for 40 minutes before finally giving him that particular. And he used to have respiratory convulsions once in a while, maybe 3 to 4 times a day. I used to consult veterinary, but whatever medicines they had suggested, I could not get it in Anand, whatever in medical stores of vet. So after giving this, I just gave it because I know the importance of probiotic. Now his respiratory, this thing is absolutely gone. He's there since birth and it was there. Now he's 3 years old, and maybe about 4 months back, I have never seen him now doing that convulsions. So, it's so wonderful. Even I am suffering from asthma since my childhood, but I can't take his, probably the pet probiotic, because the strains are important, I don't know. So even I suffer from asthma once in a while. So it's experience. I saw it and I said, let me share it over here. If it can work for a pet dog, maybe for human also, it may definitely work. Thank you. Thank you.
Thank you, Dr. Jana. Actually, we'll have to take one more trial because it is because of the buttermilk which you are using to suspend that powder, or it is because probiotic strains which are already there in the powder, or it may be a synergistic.
Probiotic buttermilk has come recently. Earlier, it was just plain buttermilk I used to give.
Because it has got bifidobacteria plus LA5 from Christian Hansen.
No idea. No idea.
Anyway, it's a good experience, and actually, I also had many experience with poultry because we have controlled poultry mortality associated with antibiotics by just feeding the buttermilk prepared with our probiotic strain, Helveticus MTCC 5463, giving through the water pipe, the diluted culture, and we have controlled mortality within 24 hours. Otherwise, because of high antibiotic doses, the birds die quickly. So there are good experiences with animals, but we are focusing more on human here, and similar kind of effects, especially for control of tuberculosis and respiratory disorders. A lot of work has been done in the old Russia, and there they were using kaffir and kumis, using mare's milk, because mares never contacted tuberculosis. So they thought that there may be something in the mare's milk, some kind of peptides which helps to control this kind of infections, and they have some reports on tuberculosis. Anyway, let us go ahead. Nirja, you want to have some comment on this, or Dr. Nirja?
No, I'm good. I'm good. That's nice to hear.
Take another questions, please, Sujit ji.
Thank you, sir. There are a lot of questions in the chat box, but before that, I personally would like to ask a question to Dr. Sanket first from my end. Dr. Sanket, you're available? Can you hear me?
Yes, he is there. He is in the plant, but he is there.
Okay, I just wanted to know, see, the freezing or lyophilization process, which sometimes, damages the probiotic cells and reduces their viability, which can be prevented by cryoprotectants or lyoprotectants. So rehydration of these dried cells is also essential, right, for maximum productivity. So when the cells are not provided with proper conditions, they're at the risk of losing their viability. And also several studies are there which has shown that depending upon the applied rehealing conditions, such as buffer, pH, duration, sugar content, and rehydration temperature as well. So there are differences in the final concentration, which can lead to the difference of one log cycle, say. So these observations suggest that a large proportion of probiotic cells may be killed or may be uncultivable depending on the rehydration conditions. So the conditions of the rehydration play a very important role in the productivity of biomass production at the commercial levels. So I'd like to know your thoughts on that.
Hello.
Can you hear me?
Yes.
Just wanted to know your
Sanjay?
having some network issues.
I think he is.
Yeah, so it's okay. In the main,
Take questions to other speakers in the meantime.
so we'll start with the.
Please unmute.
That you take questions to other speakers.
Yes,
Sankrit.
in the meantime, I'll just take the questions from the audience to the speakers. So we have questions from, is Hina there? Hina Parmar? You have raised your hand. If you want to ask, you can ask. I'll just tell the names first who have raised their hands. Dr. D.N. Gandhi, Hina Parmar, Dr. Mani, Dr. Mohan. So if you want to ask your questions, it's the right time to ask. Because after that, I'll ask the questions to our speakers, which is posted in the chat box. Dr. Kavita, Dr. Mahalakshmi, Dr. D.N. Gandhi, anybody? Dr. Hina?
Hello.
Yeah, it's Dr. Kavita Sairam. Yeah, please go ahead.
I just wanted to ask Nirja ma'am, what is the shelf life of the probiotic bacteria in most of the products it is available? Is there a way to increase it? Is anything being explored in that direction?
So it all depends on the matrix in which that particular probiotic is. So if it's in a lifetime preparation, then the shelf life could be anything between 1 year to 18 months. But if it is in the form of a fermented product, like a dairy product, then they have a shelf life. So, 20 days, 30 days, 40 days at the maximum shelf life of the product. And most of the probiotics are available as fermented foods only today. Simply because, fermented products have to be refrigerated, which ensures the viability of the probiotic bacteria. And they are consumed quickly as well. So, you ensure that you get the right strain of bacteria and the
Thank you. So, Dr. Priyanka, you're there? You had some questions? Yeah, please go ahead.
Yeah, actually, my question is not to a particular speaker, but to actually all of you. Since we are talking mostly about fermented dairy products and the new trend, or I won't say new trend, but like in past 10 years, a lot of focus has been shifting towards alternative milk options like vegan milk or almond milk and all. So what are the implications of the nutritional deficit between a dairy product and or a vegan milk? First question is that. And second, how we can include probiotics similar to which we have like buttermilk and dahi in the normal dairy industry, how we can replicate similar instances or products in the vegan milk industry.
First is that you cannot compare the nutritional value of milk with any other alternatives. Because the quality of proteins, the quality of fat, the quality of carbohydrate, which are the minerals and availability of mixture of all these things is distinctly different than any other plant-based products, which are usually synthesized and manufactured with so many other additives like stabilizers, emulsifiers, and proteins and calcium carbonate and many other things and sugar. So that is a distinctly different thing. So let us not compare all these things. It's not possible. Second thing is that probiotics. So we have a lot of work done on the non-dairy beverages and products, maybe rice-based or wheat-based or fruits and vegetable-based and juices and so. So depending on the type of the characteristics of the particular product, the probiotics may be incorporated live or it may be kept separately in the pouches and mixed, especially with the juices and so. Because of very high acidic nature, this viability of probiotics is a problem. So in that case, it is kept separate. We have seen that with fruit juices, many people put it in packaging material. Many people put it in straws as a immobilized bacteria. So these things happen. But with cereals and pulses, it's natural and it is going on. We have a very good example of the idli, dosa, dokla, khaman batter, where a lot of bacteria, lactic acid bacteria are growing. So if you have specific strains which can survive these conditions, they can be added then that kind of products. And probably not still have the organized manufacturing industries for such kind of products because it is not held at the household level or in the restaurants and other things, or maybe equally lower. But a lot of work has been done how these other non-dairy nutrients support the probiotics. If anyone want to add any comment on this, Dr. Srija or maybe anybody else, please.
Yeah. Hello. Myself. Is it audible? Myself.
Dr. Gandhi.
Yeah. Is it audible?
Hello. Yes, sir.
Hello.
Jara, loudly.
So now, okay. Just I would like to supplement some of the points which I've just listened to by various speakers, and with regard to health benefits of these probiotic culture and other fermented milk products. as far as my experience goes, since 1975, we have worked mostly on fermented milk products and probiotic. My students also worked on this aspect thoroughly, but some aspect may be left because there is always a time limit is there and facilities available. So, well, as far as I know, best benefits by these all fermented milk products is by consuming the fermented milk products rather than as compared to other tablets or capsules. In fact, those are recommended only for those people who take a lot of antibiotics. And because antibiotics destroy your intestinal organism, useful organism, that's why probiotic is also given in the form of capsule or tablet to the patient. This is what we have seen, and all these whatever is available in the market. So I don't want to mention the name. So many are there. So as well as the when you consume daily, particularly it has been recommended almost 100 to 200 grams of fermented milk product should be consumed daily in form of dahi, lassi, yogurt, buttermilk. As you also know, all these Amul dairy, lot of probiotic drinks. Even buttermilk has also started, keeping in view the benefits of the this one organism. That's why we wish that such products should be taken. If you take such products, you need not to take antibiotics because you feel healthy and healthy and feel quite fit, particularly I have seen. So I think the best way is to consume fermented milk products to take maximum benefits of these probiotic and other fermented milk products. This is what I want to add it, and I know, of course, Dr. Deja is there because this Yakult, it was started somewhere in 2010. And when it introduced, immediately some other from like Nestle, Mother Dairy, and Amul, they started. I remember all those days because I retired in 2009. Before that and after that, immediately this started. And we tried our best way to convince the people to do it, but it was not possible. Anyhow, it's why I'm very happy that a lot of work is going on this, on different aspects, and people have now a lot of awareness on this use of probiotic culture and fermented milk products. Thank you so nice of you. All the best.
Thank you very much, Dr. Gandhi. Gandhi साहब,
Right,
आपने
doctor.
तो
Thank you.
अपना तो पहला ही प्रोबायोटिक ड्रिंक एनडीआरए के पार्लर पे लॉन्च करवाया था और हम प्रोबायोटिक
Lactobacillus I worked, and I got the patent that the drink was also there. I approached many people. People were not encouraging, but now people are following same thing. I am very happy at this. No, okay. So thank you very much, doctor.
Thank you very much for your input. Yes.
Sir, I have a question. Sir, I have a question to Dr. Nirja. Hello,
Yes.
Dr. Nirja.
Yes.
I want to ask you regarding is any probiotic available for depression, because it's a problem which is being faced by the current generation, especially the younger generation. So
That's a very good question, Dr. Srija. Basically, now we know about the gut-brain axis and we know about the bidirectional communication between the gut and the brain. So there are a lot of meta-analyses which have used different strains of probiotics and have seen benefit. But Yakult is a product which has got Casein shirota, and there have been studies which have been done with Yakult on medical students who normally have a lot of stress during the exams. So what they saw was that when they gave this particular strain for a period of 8 weeks just before the examination, the levels of salivary cortisol, which is responsible for your anxiety, the levels of salivary cortisol were significantly lower in the group that got the strain of bacteria. So this is one particular strain which I know about, that where there has been a definite benefit in terms of anxiety and stress. Other than that, yes, of course, there are a lot of meta-analysis, but it's still, I think, is still in the nascent stages where we can really suggest a probiotic for depression, anxiety, or all these neurological disorders. But definitely there is a connection between the type of microbes that we harbor in the gut and your brain function.
thank you.
We have some raised hand from Dr. Mohan Manoharan. Are you there? You can ask your questions, Dr. Mohan. Please unmute yourself and ask.
डॉक्टर निर्जा आपका स्क्रीन शेयरिंग बंद करो.
अरे अच्छा बंद कर. It's coming onto the. Just look.
Yes, you can see it, what you are doing.
How do I close it? I don't know. Should I
Stop.
go and come back again?
Stop screen sharing.
Please stop screen sharing, ma'am.
Now?
It is still there. एक्चुअली ये सॉफ्टवेयर में प्रॉब्लम है, ये जो है ना अपना गो टू वेबिनार वाले में.
Now it is cut?
It's fine, ma'am.
Yes, अभी गया. Now it is gone. Nothing confidential. You have not seen anything. Don't worry.
No, I'm also preparing for the symposium at the same time. You know that, Dr. Prajapati.
I think Sujit, you should start reading the question from chat box. Actually, we should give
Yeah.
priority to them. Because you are
Correct, sir,
written
correct. We have some questions from our participants to Dr. Srija ma'am. Yeah, they're asking, sir, the question is from Dr. Chandrakala, that if there is a probiotic product, can we isolate the probiotic strain, identify and reuse in any other product? Is it legal? The question is, if there is a probiotic product, can we isolate the probiotic strain, identify and reuse in any other product? And if it is legal? It has been asked by Dr. Chandrakala.
First of all, it's very difficult to isolate the probiotic strains from such products, mainly because when we say the strain, the probiotic attributes are mainly for that particular strain, and usually the commercially available strains are being patented strains also, and when they use such strains, the specific media are being developed for isolation of that particular probiotic strain, I'm saying, because in the fermented milk products, when you use, it contains other starter strains also. So usually when you isolate, and it will be again, you cannot incorporate and call it as a probiotic product for when you are developing a new one. So that is my opinion. I think Dr. J.B. Prajapati sir can throw some more light.
I would these questions to Dr. Nirja. Dr. Nirja, if I take a bottle of Yakult from the market, I isolate Lactobacillus casei, and then I put that in other products and sell it. Is it legal?
Absolutely not.
So how will you catch me then?
No, catch me meaning what people are doing. I mean, what people are doing is, I have seen a lot of products in the market where they're using a particular strain, but they're not mentioning the name of the strain. So they're just mentioning Lactobacillus, Lacticacea, Bacillus paracasea, like that, not mentioning the complete strain of the bacteria.
I think the answer, जिसने question पूछा तो उसको answer मिल गया ना?
Yes, absolutely. I think she should be satisfied. Okay. Yeah, she has written that it's fine.
Many of the strains you cannot cultivate in the laboratory. See, we have tried many things with Christian Hansen strains, BP12 and LF5.
Yes.
You will able to produce it once only because they are auxotrophic mutants and they do not develop once you that ingredient is lost in the medium. So try करके देखो, शायद नहीं कर पाओगे किसी का भी.
कर भी नहीं पाओगे. That is absolutely true. Because absolutely नहीं कर पाओगे.
One more question for Srija ma'am from Neelam Kaushik. That is there any harmful effects of excessive consumption of fermented foods on human gut health or gut microbiota?
Can you please repeat the question, Dr. Sujit?
Yes, ma'am.
Excessive consumption of fermented foods will lead to any harm?
Yeah, any harmful effects? The question was any harmful effects.
Not at
of
all.
excessive consumption?
If you see the history, we are consuming this fermented milk products since ages. And actually, the consumption of fermented milk products traditionally has been associated with gut health. If you see the Charaka Samhita and the Shishruta Samhita, it has been reported that regular consumption of buttermilk is suggested to cure certain illnesses which are associated with the gut. So, and if you see our dietary practices also, we are consuming these fermented dairy products on a regular basis. So, it will not, one has to take care. For example, if I'm consuming, unable to consume 200 ml or maybe 300 ml, then I should not take it. So it depends on a person's ability to take how much the person can consume. Even in case of water also, the dietitians and are suggesting you take so much liters of water every day. But on a personal level, I'm still unable to consume more than 1 liter or 1.5 liters of water per day. So it again is a very personal thing, because the metabolism and everything is a very personal aspect. So accordingly, one has to decide and consume. But taking every day, it will not harm.
Actually, the gist is that consumption of fermented foods has no harmful effects. But आपने जो excessive consumption बोला, for that there is one statement in our Vedas, अति सर्वत्र वर्जयति. मतलब किसी भी चीज का excessive अच्छा नहीं होता है. That is ultimately poison. आपको लड्डू बहुत अच्छी लगती है और 50 लड्डू खा जाओगे तो क्या होगा? So it's not like that.
Many comments are like that. Thank you, Sriya ma'am, for the wonderful presentation. Is there a way to collaborate with you somehow for their work, research work?
Yes, yes, most welcome.
People are asking your address also, an email ID. So
Yeah, you can reach out to us. It is there in my, the mail ID is in my presentation, and we are there in the Camden University website also.
Dr. Sujit Das can
you please send me the link?
you can reach out to me also. I'll be more than happy to assist you for that, for connecting to SMC College of Dairy Science especially. One more thing is, ma'am, for a question from ma'am, for Shrija ma'am, how does the probiotics influence the bioaccessibility of minerals in the fermented food? From Gayatri Devaraja. How does the probiotics influence the bioaccessibility of minerals in the fermented food?
Okay. Actually the low pH conditions, it actually favors it increases the solubility, and thus it increases the bioavailability of the minerals. And you are taking it along with, when you consume a fermented milk product, you are taking it along with the other food ingredients also, which are there present in the milk, which further help in better bioavailability of these minerals.
One more question is, this is for Dr. Nirja. Nirja ma'am, it's from Mahalakshmi Palani. She's asking regarding the toxicity of probiotic strains, since it is in supplements around 50 billion CFU or at times even more. So according to FSSAI, is there any limitation regarding the toxicity?
So FSSAI does not have any guidelines for toxicity, but normally whenever you are basically introducing a probiotic strain, it is tested in animals in almost 10 times the concentration of the numbers that you're going to give it to humans. So it is tested for acute, subacute toxicity before it is formulated into a product for humans.
I hope the query has been answered. One more question. This is for Dr. Sanket. They were asking how there are stability changes with the use of bioactive peptides as functional foods and drugs. Therefore, the evaluation of peptide stability is an essential part of peptide characterization. Like scaling up production often results in irreproducible peptides. So, what are your thoughts on this?
Yes, in fact, the viability and the native structure of bioactive peptide that generated during the lab trial or say pilot plant trial, when technology is scaled up at the commercial scale is always a challenging, and probably nobody has worked upon it. I'll give you a simple example. Say, for example, when we make cheddar cheese, during ripening for 5 months, 6 months or so, I am talking about classical cheddar cheese. So there are so many bioactive peptides that are generated during those ripening biochemical changes. But when we convert that ripened cheddar cheese into a processed cheese or processed cheese spread, we don't know what happens to those bioactive peptides, because those bioactive peptides are obviously bioactive when we consume, but those are also reactive when we process it to make processed cheddar cheese or say processed cheese or processed cheese spread. Similarly, the right way is during fermentation time, say classic fermentation time is say 4 hours for dahi in laboratory. But when we go for scaling up a process, what happens if it is fermented for 4.5 hours or 5 hours, or what if acidity is achieved within 3 hours? So those things will remain there, but still it is not like there are no bioactivity. Even the random samples, fermented milk samples were tested, and there were bioactive peptides present in it. So it's always a positive and top of the whatever other nutritional significance is there. Even if we do not consider bioactive peptide, let us say the health segment, health properties of the fermented milk segment remains at the peak of the nutrition of all the food. Bioactive peptide will always over and above those nutrition provided. But yes, this issue is still not addressed properly.
I think Dr. Subrato Hati is sitting there. He can throw some light on stability of bioactive peptides. The peptides which we have collected in our laboratory, whether over fermentation or some other process, whether still they are active or they are getting destabilized. Yes,
Subrato
please,
sir, you can share your views. It will be learning experience for all of us.
I just want to add, as Prajapati sir told me to speak on, bioactive peptides. Basically, if you compare with the protein, it is around 2 to 20 amino acid residual protein chains, amino acid chains. But when the peptides are generated, the chain length is important as well as the important of the amino acid residues. Because in vitro, we generally test those peptides which can resistant these proteolytic enzymes which are present in the stomach or in the intestine, or it travels mostly intestine, it is absorbed. So those amino acids, which are amino acids have the capacity or the ability to withstand these enzymes, they are being selected for the further use as a clinical drugs, or you can say as a food. Okay. So there is a scope to check before sending through foods that these peptides may be damaged, or it should not reach to the intestine cell or the target site where it will get absorbed. So the 2 to 3 amino acid di and tripeptides, they are mostly resistant to the proteolytic enzymes, and they are rich with IPP, VP, means proline, and valine. These kind of amino acid residues are highly resistant to the digestive enzymes which are present in our GI tract, and they are don't have any kind of issues with the bioaccessibility and biostability also. And we are also doing this kind of work in our lab, that which peptides are more through in vitro digestion, not in the clinical, that which peptides are tolerating these kind of digestive systems or digestive enzymes. I think I have answered, sir.
What about the heat treatment?
Heat treatment, sir, again, we have prepared all the fermented milks by heating the milk through heat treatment, Then we add the cultures. So fermented milks, we are getting very good amount of different bioactive peptides. So heat treatment doesn't have any kind of, because you see the bioactive peptides, mostly those are highly active. They are amino acid residues within 2 to 3 amino acids. Otherwise, it will not get absorbed in the body, because the transporter will not allow you to get into the circulation system.
Anyway, I come to that. Actually, many people are selling thermized products. That means where live bacteria will be dead, but peptides will be still there. So those thermization treatments, treating up to 90 degrees, probably do not affect those peptides which are having smaller amino acid chain length, less than 5 amino acids or less than 7 amino acids. They do not further break down. So my answer, as I assume, is that it will not have any effect either through fermentation because proteolytic enzymes do not further break it down, or through other physical treatments, and hence it is safe to have those kind of products also.
Yes.
Yes, Sujit, now you can go ahead.
Thank you, sir. Thank you, Dr. Hathi. One more question. Just 1 second. The people you're writing to me, the Google form is not taking response. It will be we're working on that. So please wait for some time. Give us some time. We're working on the Google form. One more, sir. Just give me a second. I think this question is for Dr. Prajapati, sir. So, sir, it's written that. So the question is from Dr. Alam. What is the status of genetically modified probiotics for the treatment of various gut and other metabolic disorders? As such research is going on, what about its practical applicability and government status?
It's a very typical and tricky question to answer also. How many people are there on YouTube, Sujit?
So let me check this.
Because on this Zoom call, I see about 180. Because genetically modified foods and products and cultures are still not legally permitted in India. No doubt, research is not inhibited. Research can go on. Probably genetically, the live genetic material, that in terms of bacteria or maybe some food materials also, it is not permitted. But the metabolites of genetically modified organisms are already there in the market. For example, the rennet which we use for cheese manufacturing is from the genetically modified organisms like Escherichia coli or yeast. So there is a distinct category. The viable material which is genetically modified is not legally permitted in India. However, research is not inhibited. Government wants that such research may go on. It is likely that in near future, when we are very sure and comfortable about the toxicity or carry forward effects of such genetically modified foods or bacteria will be established, it may come. It may have some. At the moment, it is not, because it is very difficult to control and monitor the use of such materials and so on. However, the genetically modified products, which is end use, further it is not to be used for any other things. This kind of things are getting permission from FDA or maybe from the other food authorities. But the question is not only scientific, it is political also and regional also, and it has many angles. And so probably DBT can work on this to establish a policy paper for this, because they may be getting many queries, not only from bacteria, but many other plants and fruits, vegetables, cereals, policies, even BT cotton, BT brinjal, and many other things. They were discussed and debated in Parliament. Dr. Shilpi Gupta, if you want to put some light on this, I think it will be better.
Yeah, I wanted to say that, we get many projects wherein people want to work on recombinant strains for production of certain compound, flavor, fragrance. Even then, that, at that time also, like our committee and also the Food Safety Authority, we find it very difficult to, take forward such projects. Like there are many which have developed proof of concept and they are just held up because approvals are not there. So, yeah, we did interact with some of the members of the Food Safety Authority Committee and all, and talks are going on. Let's see, because recently they have done some upgradation wherein they allowed certain enzymes which are through recombinant roots to be used in food products. But I think still there's a long way to go.
Next question is for us only, for BIRAC only. Like, can a repository be created pan-India with BIRAC's initiative for probiotics, and also if there are any plans in this area to be carried out by BIRAC and DBT? So we are working on that. Hopefully we'll come up with something productive. Ma'am, you have anything to add on this?
What, Sujit? I couldn't get the question.
The question was,
Okay.
can a repository be created pan-India with BIRAC's initiative for probiotics? And also, BIRAC and DPT are working to promote this area, and if any new initiatives are planned.
I think probiotic repository per se is not there, but I think there are some microbial repositories within the country which DPT has created. One is like, you know, the NCCS and IMTEC. So I don't know whether they would accept these strains, but since they are a repository for microbial strains, maybe, you know, it can be
Yeah, they are
tried over there.
accepting.
It can
Actually,
be
India
deposited there, or
is
if
the only recognized repository in India for putting cultures as Indian patent deposits. But BIRAC and
NCCS also has a culture repository, no? NCCS
Yeah,
Pune.
NCCS, Pune, IMTEC, Chandigarh.
Maybe we can take forward. I mean, we'll pass on this suggestion to DBT that, you know, if they can do something about thinking of a repository specifically for probiotic strains.
And the people who want to know about BIRAC schemes, please visit our website, or you can write to us also. We will be happy to help you out on this. One more is there any training sessions for fermentation products? So it's one of our mandate of BIRAC to conduct hands-on training and workshops on different areas. So we'll let you know
maybe, yeah, you know, specifically for hands-on training, Sujit, I want to add maybe next month or early March, we might be having hands-on training on fermentation techniques at IIT Madras. So just, you know, keep on visiting our website, and the link for registration for that will open. So anybody who's interested can, you know, join that. It will be held for 3 to 4 days at IIT Madras Research Park, and we'll put, you know, the documents, the advertisement for that on our website. So you can keep on looking, and if you are specifically interested, then maybe you can send an email to Dr. Sujit, and when the link is open, he'll specifically get back to you.
Actually, I would like to inform that at Anand in Vidyadhari, we regularly conduct training programs on fermented milks and probiotics. Usually, it is every 3 months, one training program is organized for 3 to 5 days, where you can have hands-on training of pilot scale manufacturing of the probiotic fermented milks and milk products. And we are also doing some customized training programs who want to have some training programs on fermented milk-based products, and so maybe importing probiotics or a normal starter cultures also. So you can write to our principal or maybe Dr. Srija as the head of microbiology department for such trainings if there is any query into that. Thank you. I think time to conclude now.
Yeah, and I think if any other queries are there, you can write to us. We'll be happy to answer. You have our mails. Please connect through us. We'll be happy to help. So, and people who are writing for the feedback form that it is not opening, please note it will be open for next 5 days. So today's limit is over. That's why maybe you are unable to, you know, submit your forms. So
yes, we've reached to maximum certificate issue because so many people are
correct.
Clicking on the feedback form. So maximum certificates are issued. So please wait for 2 to 3 days. You will get your e-certificate, and we are also keeping the link active for 2 to 3 days. So
एक दिन में 500 से ज्यादा नहीं होगा. I think there are 1,000 people.
Yes.
So it have to take 2 days. क्योंकि 200 तो इसके अंदर है, तो उसमें 1,000 थे. So there are. It is very good, encouraging for all of us that so many students and participants are.
So we have from entrepreneurs, students, industries, companies who have joined. So I'm really thankful to everybody who have joined. And also we'll have continuation of this webinar series in February 8th and 9th also. So those who were unable to register for this session, please visit the BIRAC website. You can register for that February webinar series, which is going to be held from 8th to 9th February. Thank you.
Thank you, Dr. Sujit. Thank you.
Okay, thank you so much, everybody.
Thank you, J.V. Prajapati sir, for conducting this session so nicely.
A very good discussion.
Thank you all
these people.
Yes, sir.
So, probably now Dr. Mittal will conclude. Yes, Dr. Mittal, continue.
Yeah. Yes, sir. Thank you, sir. Thank you all the speakers for answering all the questions. Thank you, Dr. Sujit. for sharing all the questions on behalf of participants. So here we come to the end of second day of webinar. I would like to thank everyone on behalf of organizing team for the successful completion of 2-day webinar on the topic biomanufacturing of probiotics and fermented foods, a step towards health status and social well-being. I would like to start by thanking our great sponsor, Biotechnology Industry Research Assistant Council, BIREC, Dr. Shilpi, Dr. Sujit, and the team members for trusting us and providing the opportunity to conduct such webinar. I would like to express my great appreciation to our dignitaries who have taken time out of their busy schedule and grace this occasion with their virtual presence. I would also like to thank our principal sir, Dr. Jana sir, for his constant support and being always there to encourage us to conduct such functions. I also would like to express my heartfelt gratitude to the invited speakers for accepting our invitation and sharing your invaluable experience with the participants. I'm sure that everyone is going with some takeaways from this 2 days deliberation. My heartfelt thanks also goes to respected Dr. J.B. Prajapati sir for accepting our invitation and for conducting the open discussion so nicely. I also like to thank Dr. D.R. Shah sir, Managing Director Vidya Dairy, for providing the facility to organize this webinar. At last, thank you so much, dear participants. Without you, this program is not possible. Thank you everyone. And like Dr. Sujit said, we are also organizing another 2-day webinar with same theme, but with different topics and different speakers. So do register for the next month's webinar. The details regarding registration are already available on BIREC website and Kamdhenu website. I hope to see you all again on 8th and 9th February next month. Thank you everyone.
Thank you so much.
Okay, thank you so much.
Thank you.
Thank you, sir. Thank you, sir.
Bye bye, Dr. Nirja.
Thank you. Bye.
See you soon. Bye.
Thank you, sir. Bye.